What's good? What's good? So I am about to go through a bunch of PDF lectures from my C++ class because I have a project due today that I've been shirking the responsibility of preparing for adequately because I've been preparing for my interview process. But now that that's in a place where I can feel confident about it, I'm about to binge all of my lectures or the lecture slides from my class. So it's hopefully I'm gonna be able to get through 16 chapters. But yeah, let's just go into it. So starting from the beginning, C++ programming introductory lecture. And just so you know, I'm going to zoom through these and only slow down when I feel like I'm learning something that I didn't have a firm grasp on, right? So especially for these first slides, there's going to be a lot of stuff skipped, but just letting that be known. So let's go. Okay. So let's get to the juicy stuff. Hardware, software, physical devices. Got you. Software instructions. Yep. Got you. Program set of instructions. Compiling a program. Source code goes into a preprocessor. Goes into modified source code. Goes into a compiler. Goes into object code. Goes into a linker. Goes into executable code. These are the special characters in C++. You got a double slash is the beginning of a comment. A pound sign is the beginning of a preprocessor directive. Open and close brackets and close file name in pound include. Open close parentheses used when naming a function. Open close brace encloses a group of statements. Open close quotation marks encloses a string of characters, and a semicolon is an end of a programming statement. Cout, end line, escape character, include directive, inserts the contents of another file into the program. This is sometimes called a macro. A macro is a preprocessor directive. Some people refer to a macro as not part of the C++ language, even though it is difficult to avoid using at least some macros. The include lines are not seen by the compiler because each include line gets replaced by the contents of the included file. Do not place a semicolon at the end of the include line. So variables is a storage location in memory, has a data type and a name, must be defined before it can be used, like int item. Literal is a value that is written directly into a program's code, like a string literal or an integer literal. An identifier is a programmer defined name for some part of a program. Variables, functions. Identifier rules, the first character, yep, got you. Okay, cool. Int my data is not the same as int lowercase my data. Names matter. If you choose good names, they can help you. A good name should be descriptive. Think about how and where a variable used. If a variable is referenced only on a few lines of code that are close to each other, then a very short variable name might be okay. Otherwise, you want to be descriptive. Got you. Integer data types. You have a short int, a unsigned short int, an unsigned int, a long int, an unsigned long int, a long int, and an unsigned long int. Defining variables. Variables of the same type can be defined on separate lines, on the same line. Variables of different types must be in different definitions, usually on different lines. Integer literals. An integer literal is an integer value that is typed directly into a program's code. So 15. Constants that begin with 0 are base 8. Constants that begin with 0x are base 16. So char data type, a variable of type char can hold a single character of a very small integer value, usually 1 byte of memory. Numeric value of character from the character set is stored in memory. So code char letter equals C, and the memory stores 67 because that's the ASCII code. Character literals must be enclosed in single quotation marks. So two kinds of strings in C++. C strings are null terminated arrays of characters, a series of characters in consecutive memory locations, hello, stored with a null terminator, \0 at the end. Objects of the string class, a series of characters in consecutive memory locations. A string literal contains the characters between the double quotes and a null terminator at the end. A null terminator is a character that has the numeric value of 0. We usually express the null character as \0. We sometimes draw a diagram to illustrate these details like this. A string literal is an example of a C string. The C string, C+ string class, special data type that supports working with strings, requires include string statement. You can define string variables in programs like that. You can set string values using the assignment operator like that. You can display string variables using cout. So for floating point data types, the floating point data types are float, single precision 4 bytes, double precision 8 bytes, long double precision 8 or 10 bytes. They can hold real numbers such as 12.45 or negative 3.8. All floating point numbers are signed, stored internally in a form similar to scientific notation. Sometimes floating point numbers get displayed in a scientific notation form. We would really prefer that they be displayed in a more intuitively obvious form. We will learn how to use the set width directive to control this, or actually I assume that that's set width. I call it that. We'll say set W. We'll learn that later, right? So scientific notation, sometimes people need to work with numbers that are either very large or very small. Rather than write numbers with many digits, a standard called scientific notation is used. So the number 10 in scientific notation is 1.0 times 10 to the 1. In C++, they use E notation, and it's signed, so 1.0 E plus 1. Good to know. So floating point literals can be represented in fixed point decimal notation, 31.4159, 0. All those zeros, 625, or E notation, 3.14159 E1. So it doesn't have to be signed. Good to know. 6.25 E minus 5. The data type of a floating point literal is double by default. Again, the data type of a floating point literal is double by default, but the language does provide a way to specify as float or a long double. The bool data type represents values that are true or false. So bool variables are stored as small integers. False is represented by 0, true by 1. Determining the size of a data type. The size of operator gives the size of any data type or variable. So you could do a double is stored in size of double bytes, and it'll say a double is stored in 8 bytes. Sample program, okay, cool. Arithmetic operators used for performing numeric calculations. C++ operators can have either 1, 2, or 3 operands. So unary is applying this negative, binary is doing a subtraction, and ternary is this expression 1 question mark, expression 2, and this colon acts as an otherwise. So it's if expression 1 is true, do expression 2, otherwise expression 3. Binary arithmetic operations, all the standard ones. Closer look at the division operator performs integer division if both operands are integers. So 13 divided by 5 displays 2, rather than, what would that be? 2 and some change. If either operand is floating point value, the result is floating point value. So 13 divided by 5.0 displays 2.6. A closer look at the modulo or modulus operator computes the remainder resulting from integer division. So 13 modulo 5 displays 3. Modulo requires integers for both operands, so this is an error. Line comments begin with double forward slash through to the end of the line. So int length equals 12 forward slash length inches. These calculate, or you could do this calculate rectangular area. Got you. Block comments begin with slash asterisk and end with asterisk slash. Can span multiple lines. Can sometimes begin and end on the same line. Sometimes called multi-line comments, even though they might only occupy one line. Named constants, a variable whose value cannot be changed during program execution. These values are initialized at compile time but never change while the program is running. Used for representing constant values with descriptive names. So const double tax rate equals 0.0675, or const int num states equals 50. And again, named constants their value cannot be changed during program execution. They're initialized at compile time, but never change while the program is running. Programming best practice, you use them with uppercase letters with an underscore character separating words within the name. So programming style, remember that we were writing for 2 audiences, so make it look juicy. Improving readability, the way you format your code. Got you. The cin object, so like see how it requires include IOStream. You use these arrows. And displaying a prompt is a message that instructs the user to enter data. You should always use cout to display a prompt before each cin statement. Cool. So that's chapter 1 and chapter 2. Let's go to 3 and 4 now. Let's get rid of that. So chapter 3, expressions and interactivity. Chapter 4, making decisions. So let's go to the good stuff. Chapter 3, expressions and interactivity. The cin object, keyboard input. As we've already seen, the cin object is used for input from the keyboard. It requires include IOStream. Input can be retrieved from cin with the stream extraction operator. Input data obtained using the stream extraction operator stored in the variable named to the right of the operator. So cin arrows hours. Do not forget to display a prompt. Yep. Reading values of different types. Program 3.3 asks the user to type input of different data types and then outputs the variables. So we have include IOStream using namespace standard, int main, int whole, double fractional char letter, enter an integer, a double, and a character. So we do cin whole fractional letter, and then we do so reading values of different types too. You could do whole is whole end line, fractional end line, letter is letter end line, and this is a much better way to do it. And looking good. The keyboard buffer input looks like this, but what if the user enters the data in the wrong order? So you get bad output because the buffer gets all messed up. First variable, red is 5. Yep. Mathematical expressions. We can create complex expressions using multiple mathematic operators. An expression can be a literal, a variable, or a mathematical combination of constants and variables. We can use an expression as part of an assignment statement, cout statement, and other statements. For example, calculating the circumference of a circle. You do 2 times pi times radius, or the border perimeter of a rectangle, assuming L stands for length and W stands for width. You can do 2 times parentheses L plus W. So this is talking about order of operations, but those are pretty standard. Associativity, unary negation associates right to left. All of these associate left to right. Parentheses can be used to override the order of operations. Grouping with parentheses makes sense. Algebraic expressions. So take care when converting algebraic expressions to C++. Multiplication requires an operator. Yep, there's no exponentiation operator. You have to use this POW function. Parentheses may be needed to maintain order of operations. So that becomes this. Operator precedence and associativity. When in doubt, make your intent clear by using parentheses. Beware of fancy fonts in this table. Okay. And this is the order of operations and precedence and associativity. So now chapter 4, making decisions, relational operators, all the standard stuff, or at least if you're familiar with Python, because you watched my other videos, then, you should, it's all basic stuff. Feels gross to even say that stuff. But anyway, relational expressions, Boolean expressions, true to false, yep. Examples, suppose these variables have been initialized as shown. So got you, then this will evaluate as shown below, makes sense. The if statement, general format. So if parentheses expression, then statement. The expression is evaluated. The statement executes only if expression evaluated is true. If statement with block of statements. Whenever multiple statements are required to be controlled by an if statement, those statements must be enclosed in curly braces, forming a block of statements. So if parentheses expression, curly brace open, statement 1, statement 2, statement 3, curly brace close. The if and if else statements. So if statement general format, if expression statement, if else statement general format, if expression statement 1, else statement 2. Suppose statement 2 after the else is another if statement. We can chain together multiple if else statements to achieve a structure that ultimately executes one of many statements. So if expression statement 1, else if expression statement 2, else if you could do other else ifs within this, and else if expression statement n. Flags, a flag is a variable that assigns a condition. A flag is a variable that signals a condition, usually implemented as a bool variable. The value of an expression can be assigned to a variable, so result equals x is less than or equal to y, parentheses added for clarity, assign 0 for false, 1 for true, can also be an integer. The value of 0 is considered false. Any non-zero value is considered true. As with other variables in functions, must be assigned an initial value before it is used. Operator precedence. Suppose the example in the previous slide did not have parentheses. How would you figure out exactly what it means? You use operator precedence. Logical operators, you have and, or, and not. Standard stuff. If the parentheses were omitted, would the meanings be different? Use the operator precedence. Even if an expression would give the desired result based on operator precedence, there's no harm in adding parentheses to make the meaning clear to the human reader. Comparing characters. Characters are compared using their ASCII values. So A is less than B. Since A is 65 and B is 66, it's true. 1 is less than 2. but these are the string versions of 1 and string of 2, or I guess character versions really. But 1 is 49 and 2 is 50, so still true. Lowercase letters have higher ASCII codes than uppercase letters, so lowercase a is greater than capital Z. Comparing string objects, like character strings are compared using the ASCII values of the characters in the string. Strings are compared on a character by character basis. So Mary and Mark get compared by their characters. The conditional operator, format expression 1, question mark, expression 2, colon, expression 3. If expression 1 is true, then evaluate expression 2, otherwise evaluate expression 3. Parentheses may be needed in expression due to the precedence of the conditional operator. Alternative to the conditional operator, you could use an if-else. Personal advice, think twice before using the conditional operator. It is often less clear than the alternative and more prone to programmer errors. You have the switch statement, so switch expression, which is an integer expression. Case expression 1, statement S, case expression 2, statement S, all the way to case expression N, statement S, or default statement S. So switch statement requirements: 1, expression must be an integer variable or an expression that evaluates to an integer value. The expressions, expression 1 through expression N, must be constant integer expressions or literals and must be unique within the switch statement. The default case is optional but recommended. It can be useful for catching unexpected values of expression. Switch statement, how it works. First, the expression is evaluated. Second, the value of expression is compared against expression 1 through expression N. If expression N matches the value expression I, the program branches to the statements following expression I and continues, and continues to the end of the switch. That's an important thing to note, right? So if expression matches value expression I, so you could say if it matches expression 3 and we have all the way till expression 8, then the program branches to the statements following expression 3 and continues to the end of the switch. If no matching value is found, the program branches to the statement after default. Break statement, used to exit a switch statement. If it is left out, the program falls through to the next case. Statements in the switch statement. This may be exactly what you want. If 2 or more cases need exactly the same processing, then it may be correct for the switch statement to fall through to the next case. Additional note about the break statement. We will see in the next lecture that the break statement is also useful when writing loops. So here's an example of the switch statement. Prompt for command input. Enter single letter command. We get the command. Switch based on the command. Case D, so that's the deposit command. Enter deposit amount. Cin amount. Balance equals balance plus amount. Break. Otherwise, if they enter Q, then we do the quit command. If they enter X, we do the exit command, exit 0. Think before you code in general. Before you try to write a program to solve a problem, you should understand how you would proceed if all you had to work with was pencil and paper. Understand the step-by-step process for a solution before you express it correctly. Nice. Chapter 5, Loops and Files. Introduction to Number Systems. So we have the increment decrement operators. Plus plus is the increment operator. Value plus plus is the same as value because value plus 1, and decrement is minus minus, so val minus minus is the same as val equals val minus 1. It can be used before a variable as a prefix or after a variable postfix. Plus plus val or val plus plus, minus minus val or val minus minus. Prefix postfix examples. So if we have int num and val equals 12, cout val plus plus displays 12, but val is now 13, whereas cout plus plus val sets val to 14, then displays it. And similarly, num equals minus minus val sets val to 13 and stores 13 in num, and num equals val minus minus stores 13 in num and sets val to 12. Notes on increment and decrement can be used in expressions. So result equals num plus 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 minus minus num2 must be applied to something that has a location in memory. We cannot have result equals parentheses num1 plus num2 close parentheses plus plus. Can be used in relational expressions. So if plus plus num is greater than limit, pre and post operations will cause different comparisons. Be careful with complex expressions. If code is tricky to understand, then it's also tricky to be sure it is correct. So got you. Introduction to while loops. The while loop. Loop, a control structure that causes a statement or statements to repeat. General format of the while loop. So while parentheses expression statement. statement can also be a block of statements enclosed in curly braces, no semicolon after expression. The while loop is a pretest loop, so the expression is evaluated before the body of the loop executes. For example, the body of the following loop will never execute: int number equals 6, while number is less than or equal to 5, cout hello new line, number plus plus. The do while loop, do while a post test loop, execute the body of the loop, then test the expression. General format, do statement while expression. Note that a semicolon is required after expression. The for loop, useful for a counter controlled loop. General format for initialization, test, update, and then the statement. No semicolon after the update expression or after the closing parentheses. For loop mechanics, for initialization, test, update, statement. 1. Perform initialization. 2. Evaluate test expression. If true, execute statement. If false, terminate loop execution. 3. Execute update, then reevaluate test expression. For loop example, so if we have int count, for count equals 1, count less than or equal to 5, count plus plus, cout hello, and line. When to use the for loop in any situation that clearly requires an initialization, a false condition to stop the loop, an update to occur at the end of each iteration. The for loop is a pretest loop. The for loop evaluates its test expression before each iteration, before executing the body of the loop. So it is a pretest loop. For example, the following loop will never iterate. That is, the body of the loop will never execute. So for count equals 11, count less than or equal to 10, count plus plus. It's not going to execute because count is never less than or equal to 10. Sentinels, a value in a list of input data that indicates end of data. Special value that cannot be confused with a valid value, e.g. -999 for a test score, used to terminate input in a loop when the programmer and the user may not know how many values will be entered ahead of time. Deciding which loop to use, the while loop is a conditional pretest loop. Iterates as long as a certain condition exists, a good choice for validating input. Reading lists of data terminated by a sentinel. The do while loop is a conditional post-test loop, always iterates at least once, also good for validating input. The for loop is a pretest loop, has built-in expressions for initializing, testing, and updating the loop control variable, good for situations where the exact number of iterations is known. Breaking out of a loop, if we need to terminate the execution of a loop before the loop control statement would normally end the loop, we can use a break statement within the body of the loop. See also section 5.12. Break statement when used to exit a loop. A break statement will cause the loop to terminate. For example, while true, we could have if exit condition, then break. The continue statement, we can use a continue statement to go to the end of the loop and prepare for the next repetition. So while, do while loops go to the test and repeat loop if the test passes. For loop, perform the update step, then the test and repeat the loop if the test passes. And again, we can use a continue statement to go to the end of the loop and prepare for the next repetition. While, do while loops go to the test and repeat loop if the test passes. For loop, perform the update step, then the test and repeat the loop if the test passes. Nested loops. A nested loop is a loop inside the body of another loop. Inner, inside, outer, outside loops. For row equals 1, row less than or equal to 4, row plus plus is the outer, and for column equals 1, column less than or equal to 3, column plus plus is the inner. Cout row times column and line. Nested loop notes, the inner loop goes through all repetitions for each repetition of outer loop. The inner loop repetitions complete sooner than outer loop. The total number of repetitions for the inner loop is the product of the number of repetitions of the two loops. Breaking out of a nested loop, when a break statement is used in an inner loop, this terminates the inner loop only. The outer loop proceeds to execute normally. So section 5.11, using files for data storage. Files useful for input and for output. We can use text files instead of the keyboard for program input. We can also use files to hold program output. Common practice, design a program so that the same file created as output can later be used as input to the same program. For example, word processors, text editors, this dual use capability does not happen by accident. The code must be carefully written so that the format layout of the required input file is the same as the output file. Normal process for using a file. The normal steps for processing a file are open the file, use the file, read from, write to, or both, and close the file. Files, what is needed. Use fstream header file for file access, file stream types, ifstream for input from a file, ofstream for output to a file, fstream for file input or output. Define file stream objects, ifstream in file, ofstream out file. Again, like use fstream header file for file access. We have ifstream for input from a file, ofstream for output to a file, fstream for file input or output. Define file stream objects, ifstream in file, ofstream out file. Opening files. Create a logical link between file name outside the program and a file stream object inside the program. Use the open member function, infile.open, inventory.dat, outfile.open, report.txt. Again, use the open member function. File name may include drive, path info. Output file will be created if necessary. If a file with the same name already exists, then its previous contents will be erased. Input file must already exist for open to work. Testing for file open errors. Can test a file stream object to detect if an open operation failed. So infile.open test.txt. If not infile, see out file open failure. Can also use the fail member function. Using files that contain text. Can use output file object and the arrows to send data to a file. So out file, arrow, inventory report. And that's again the stream insertion operator, I believe. Can use input file object and the stream extraction operator to copy data from file to variables. So in file arrows part num, in file arrows quantity in stock, arrow quantity on order. Again, that's using the input file object and the stream insertion operator or extraction. I forget. Let me So right arrows are stream extraction, which makes sense. Left arrows are stream insertion. Okay, got you. Right, extract, left, insert. Right, extract. So this is out file, the stream insertion operator, inventory report. Makes sense. We're inserting inventory report into our out file. And then we can use an input file object and the stream extraction operator to copy data from file to variables. So in file, stream extraction operator part num, in file, stream extraction operator quantity in stock, stream extraction operator quantity on order, reading a complete line. Sometimes the best way to approach a problem is to process one complete line of text at a time. Usually this involves a loop that reads one line of text from the input file and processes whatever text was read. The getLine function happens to return false if the end of file has been reached, so it is very convenient to structure the program using a while loop. So string input text is an empty string, while getLine input file input text. Do those statements. The sample program got you. I'll be right back. Let me just grab some more coffee because I need to focus. This stuff isn't really sinking in. Man, I don't know if people have, I mean, I'm sure people have better ways of studying and committing stuff to their brain than me, but I gotta brute force it, you know? I just have to do this type of stuff, just read it. Honestly, it's better if I write it out. Just don't have the time to do all of that with all this. You know, this project is technically due today, but the teacher gives leeway. So if I get it in within 24 hours, there's no points taken off. And for each day after that 24-hour period, there's 1 point taken off with a maximum of 30 days. So I'm going to try to get the project itself done today. That's why I'm doing this studying. But if I can't, I'm not going to be too upset. I can try to get it done tomorrow And worst comes to worst, I'll get it done this weekend when I have some time. But just just gotta get caught up. So where were we? Let me go back here. So again, we have opening files. We use these the fstream header file, ifstream, ostream, and fstream. We use .open method to open files for both input and output. We can test for file open errors with the if not in file, then the statement. Use files that contain text. We can use output file object, and to send data to a file. We can use the input file object to copy data from file to variables. Sometimes the best way to approach a problem is to process one complete line of text at a time. This usually involves a loop that reads one line of text from the input file and processes whatever text was read. The getLine function happens to return false if the end of file has been reached. So it is very convenient to structure the program using a while loop. String input text equals an empty string, while getLine input file input text. I'm just gonna go ahead and save this because I already know this is like something that's necessary for my project. Put it in my C++ folder. Using loops to process files. If the input file contains only data values for a particular variable, then it can be very convenient to use a while loop to process the data. The stream extraction operator returns true when a value was successfully read and false otherwise. A simple while loop can read the data and test for end of file at the same time. So while input file is going to number, we can do that. Honestly, all this stuff is pretty pertinent. Let me just notice I missed one, put it in the wrong place. Slides, cool. So, did I get this one? Using loops to process files. Damn. Sorry. I just gotta save this stuff. Documents. I wish it oh, testing. Forgot to name that, but it's fine. And closing files. Use the close member function in file.close, out file.close. Don't wait for operating system to close files to end the program. Got you. Letting the user specify a file name. So the open member function requires that you pass the name of the file as a null terminated string. It's also known as a C string. So ifstream input file.open data file.txt. But what if the desired file name is stored in a string object? Visual Studio can accommodate this case, but some systems can't. String file name, enter the file name, cin file name, input.open, file name.cstring. So formatting output, the programmer can control how output is formatted for a numeric and string data. Size, position, number of digits, requires IOManip header file. These features are useful for formatting output to cout as well as output to a file. Stream manipulators used to control how an output field is displayed. One stream manipulator affects only the next value displayed. So set W, X, print in a field of at least X spaces wide. So yeah, it is set width. Uses more spaces if field is not wide enough. That is, it will compromise the cosmetic alignment rather than truncate the output. Nice. Floating point stream manipulators, some affect the values until changed again. So fixed, use decimal notation for floating point values. Set precision when used with fixed. Print floating point value using X digits after the decimal. Without fixed, print floating point value using X significant digits. Show point, always print decimal for floating point values. Those are some examples. Introduction to number systems. So this isn't that pertinent right now, honestly. I can skip this for now. So chapter 6, functions. Take a sip. It's lukewarm and gross. What are we doing? Modular programming. Is this the start? Yeah, okay. Modular programming, designing a program with small manageable functions or modules. Function, a collection of statements to perform a task. Motivation for modular programming, allows easy reuse of sections of the code, allows grouping of code into sections that are logically related, allows isolating details of one section from other parts of the program, improves maintainability of programs, simplifies the process of writing programs, especially when there are multiple programmers working on the same project. So we have function definition, the actual statements that make up a function, the function call, a statement that causes a function to execute, a function declaration, a statement that tells the compiler about the function that has not been defined yet, also called the function prototype. So function definition includes the function header, the return type, data type of the value that function returns to the part of the program that called it, name of the function, function names follow same rules as variables, and parameter list, variables containing values passed to the function body, statements that perform the task, enclosed in curly braces. When we refer to the compilers being happy, what we really mean is that there were no compiler errors when we ran the compiler for a particular source code file. The C++ compiler translates the source code in the order that the code appears in the source code file. The compiler does not like to see your code use a function that it has not heard of yet. Before a program actually uses a function, we need to make sure that the compiler knows about the function. Function prototype, function declaration. There are two ways to notify the compiler about a function before it called to the function. One, organize the source file so that the function definition is ahead of any code that calls the function. Two, use a function prototype, function declaration before any code that calls the function. The syntax for a function prototype looks somewhat similar to the function header, but with some key differences. The parameter types must be present, but the parameter names are optional. The function prototype must end with a semicolon. Sending data into a function. If a function is defined with calling parameters, then the caller can pass the values of variables into the function at the time of the function call. So C equals pow AB. Values passed to a function by the calling function are called arguments. Variables inside a function that hold the values passed as arguments are called parameters. So in this case, even though A and B are the arguments to the pow function, the pow function has the parameters base and exponent. Getting data out of a function. Normally a function sends data to the caller by returning some value. The code inside the function uses a return some value statement to send data to the caller. In the example below, whatever value pow is stored in variable C. In the following function prototype, the data type of the value returned by the function is to the left of the function name, so double is what it returns. Parameters, prototypes, and function headers. Function prototype must include the data type of each parameter, but not necessarily the parameter name. The function header must include a declaration for each parameter. So int calculate int is the prototype, int calculate int num is the header, calculate val is the call. Function call notes, a value of argument is copied into parameter when the function is called. A parameter scope is the function that uses it. Only parameters inside the function can use that parameter. A function can have multiple parameters. For each parameter, there must be a data type listed in the function prototype and a parameter declaration in the function header. I'm just going to read this again. Parameter scope is the function that uses it. Only statements inside the function can use that parameter. Passing data by value, pass by value. In the examples that we have seen so far, when an argument is passed to a function, its value is copied into the function's parameter. If the code inside the function changes the value of the parameter, then that change does not modify whatever value the caller passes an argument. Changes to the parameter inside the function do not affect the value of the argument. From the caller's perspective, passing info to parameters by value. Example, int val equals 5, calculate val. So val 5, argument in calling function. Num 5, the parameter in calculate function. When we do this, passing the value 5, calculate can change variable num, but it will have no effect on variable val. Got you. So value returning function, return type, the value being returned. Default parameters, a function may be defined with default values for some or all of its parameters. Any parameters that do not have a default value must precede in the parameter list those with default values. Arguments in the calling code for parameters that have default values are considered to be optional. We'll call the function either with or without those arguments. The default value of a parameter should be stated in the function prototype if present, or in the function header. Default parameter as an example. So in this example, the second parameter has a default value equal to 2. Default values in functions. So int divide, int a, int b equals 2. Inside of it, we have int r equals a divided by b, and return r. If we call the divide function with only one argument, then the second parameter has its default value. So if we do divide 12, it divides it by 2. But if we do divide 20 and 4, it'll divide 20 by 4. Local variable lifetime. A function's local variables exist only while the function is executing. This is known as the lifetime of the local variable. When the function begins, its local variables and its parameter variables are created in memory. And when the function ends, the local variables and parameter variables are destroyed. This means that any value stored in a local variable is lost between calls to the function in which the variable is declared. Initializing local variables. Local variables are not automatically initialized. They must be initialized by the programmer. So double get base pay, double hours worked. Double get base pay to hold base pay. Determine base pay if hours worked is greater than base hours. Base pay equals base hours times pay rate. Else, base pay equals hours pay times pay rate. Return base pay. In this case, it looks like base hours and pay rate are global constants. Reference variables as parameters. A reference variable is an alias for another variable. Reference variable is an alias for another variable. A mechanism that allows a function to work with the original argument variable, the variable named in the function call, rather than a copy of the argument, allows the function to modify values stored in the calling environment, provides a way for the function to provide more than one output value to the caller, passing by reference. A function may pass parameters by reference rather than by value. Reference parameters are defined with an ampersand. Void get dimensions, int ampersand, int ampersand. Changes to a reference parameter are made in the variable it refers to. That is, the change is reflected in the caller's variable. Again, a function may pass parameters by reference rather than by value. Reference parameters are defined with an ampersand. So void get dimensions, int ampersand lets you know that it's expecting references to be sent, not values. Changes to a reference parameter are made in the variable it refers to. That is, the change is reflected in the caller's variable. Reference parameter notes. Each reference parameter must contain ampersand. Space between type and ampersand is unimportant. Must use ampersand in both prototype and header. The argument passed to reference parameter must be a variable, cannot be an expression or constant. Again, must use ampersand in both prototype and header. The argument passed to reference parameter must be a variable, cannot be an expression or constant. Global variables can be bad. Using global variables instead of passing parameters to a function can be very tempting, especially for a beginner programmer. In general, you should minimize the use of global variables. They make it more difficult to reuse your function at more than one location within the program. If some other part of the program modifies the global variable, then it could cause the function to fail or give incorrect results. If you do decide to make a variable global, be sure that it is really global to the entire program. Global constants are not so bad. Ideally, any global that you create should be a global constant. For example, this const double text rate equals that. Overloading functions. Overloaded functions have the same name but different parameter lists. Can be used to create functions that perform the same general task but take different parameter types or a different number of parameters. The compiler will determine which version of function to call by the data types of the argument and parameter list. Function signature. Function signature includes the function name, the data types of the function parameters in the proper order. Note that the function's return value is not part of the signature. Again, function signature includes the function name, the data types of the function parameters in the proper order. Note that the function's return value is not part of the signature. The exit function terminates the execution of a program, can be called from any function, can pass an int value to operating system to indicate status of program termination. By convention, exit status equals 0 indicates success, no errors. Requires C standard lib header file. Command loop sample program. Okay, cool. That's chapter 6. Next up is binary numbers and bitwise operations, which is not really that pertinent to my program, but it's something that I don't have a firm grasp on, so I'm going to read it anyway. But real quick, I'm going to go heat up some. It's okay. Nothing major. Yeah, I'll be right back. One thing that's on my mind about C++ is like, for some reason, even though Python is more useful to me and what I want to do, there's something sexy about being really good at C++. It's like, and I mean that like metaphorically, right? It's a lower level, and so it's like cooler in my view to say like, oh yeah, I've mastered C++. Mastering Python is awesome too, but it does feel a little bit like writing in crayon with Python versus writing with like a fine ink pen, or it's like Comic Sans versus Times New Roman. I'm doing Python a little bit dirty, but as I get better at it, I kind of realize, and I think C++ isn't the best example of this. Although actually I think it's a pretty good example because, yeah, is it more official to be a master of C? Yes. And do I want to get good at C at some point? For sure, at some point. I don't know about how near term that'll be, but, working your way down into lower level languages just seems like a natural progression for any programmer. And I'm still early in my career. And right now, the most important thing for me to master is whatever is most useful to the work that I'm doing. And that's Python in the short term. Well, honestly, in the shortest term, that's C++ because I have that project due. And also Java. So this probably won't be the last time in the near future. Really within this next month and a half until my semester's over. I'm going to be doing a lot of videos on C++ and Java and data structures too, just because those are three classes that it's really important I do well in and finish out the semester strong. But something about Java is like the opposite of sexy to me. I don't like Java. Yeah, I don't know what it is. It's just something about its syntax, and it carries over into JavaScript too. I much prefer the way that Python and C++ feel versus Java and JavaScript, but especially Java. Maybe it's because my teacher, I'm not gonna bash him, but his teaching style is antithetical to mine, and I didn't do myself any favors by taking him 2 semesters in a row. But I mean, last semester, even though the style wasn't that well, I was able to teach myself and still get, an A in the class. This semester, it's going to be harder to teach myself, although probably what I'm going to do is, the thing is, like with this professor, all the chapters and the main topics are available as slides and video lectures and sample programs. That is ideal for the way that I learn, because I like to teach myself. I haven't really been doing the video lectures, but reading these slides, coding out the sample programs, and working on the projects, that's how I learn. Whereas with my Java professor, there's no slides, there's sample programs, I guess, but you got to watch his lectures, and that's just not how I learn. And there's a lot of empty, dead air where it's not very pertinent to what we're, to learning things, and that feels like a waste of time. Regardless, what I'm probably going to end up doing, is just doing something like this, where I watch all the lectures on 2 times speed and try to really let everything sink in. But yeah, I don't want to bore you with that. You're not here for that. But I'm just trying to talk while I drink some coffee. But let's get back to it. So, binary numbers and bitwise operations. Sorry. Low-level details of computers. So at the lowest level, a computer is an electronic device made up of many small circuits. We say that the circuitry is digital because each internal circuit can have one of 2 distinct states: off versus on, false versus true, no versus yes, 0 versus 1. Computer hardware organization. The digital circuits inside a computer are organized as a large number of building block circuits called logic gates. We can understand these logic gate circuits by considering the basic categories of logic circuits: inverter, logical not circuits, and circuits, or circuits, exclusive or circuits. The C++ programming language has the capability of manipulating data at this very basic level. Simple logic circuits: not, one input, one output. The output is true if the input is false. Also called negation or an inverter. We can represent this with a truth table. Simple logic circuits: and 2 or more outputs, one true. The output is true if all inputs are true. So again, using this, what do they call it? A truth table. Simple logic circuits: or 2 or more inputs, one output. The output is true if any input is true. And exclusive: or 2 inputs, one output. The output is true if either input is true, but not if both are true. C++ bitwise operations. C++ provides a way to use these logical operations on a bit-by-bit basis. So bitwise negation is tilde, bitwise and is an ampersand, bitwise or is a pipe, bitwise exclusive or is an up arrow. Be careful not to confuse the bitwise operators with the logical operators, double ampersand and double pipe, used with integer data types only, so char, short, int, long, all that. Bitwise not operation. The bitwise not tilde operation inverts each bit in an integer expression. Each 0 bit gets replaced by 1 bit, and each 1 bit gets replaced by 0. So if we have this, it becomes that. Bitwise AND operation. The bitwise AND operation does a logical AND of the corresponding bits of each operand. So this and that, since they only share these ones, we get back this. Bitwise OR operation. Bitwise OR operation does a logical OR of the corresponding bits of each operand. For example, this or that. We get back this because it's taking all the ones Exclusive OR operation. The exclusive OR, the upward arrow or a hat as you could call it, operation does a logical exclusive OR of the corresponding bits of each operand. So this exclusive OR this, and you get back only the ones where they differ. Bitwise left shift. The left shift operation, I just want to make sure I was right on that. Bitwise left shift. The left shift operation does a shift of the bits by the indicated number of bits. For example, this shifted 2, and you get back these ones shifted to the left 2. A left shift 1 bit is the same as multiplying by 2. Bitwise right shift, same idea, you're shifting them right. And one right shift by 1 bit is same as dividing by 2. Right shift 2 bits, same as dividing by 4. Treat it like base 2, because it's binary. This is decimal, binary, and hex. I'm not going to memorize that. Remember different sizes of integer. We often, okay, got you. Got you. Suppose we want to copy all the bits from unsigned int original data into another variable called result, except we want to be sure that result has all 0 bits in digit 1. Start by creating a mask variable with all 4 bits of digit 0 set to 1. Unsigned int mask 0xf. The resulting bit diagram is shown below. Example, clearing specific bits. Next, shift the mask so that it lines up with digit 1. Because each hex digit contains 4 bits, we wish to modify digit 1, shift the mask variable left by 4 bits, or shifting over here. Mask. So originally, int mask was this. Like OXF is this. Then we shifted left by 4, so now these ones are here. Invert all the bits of the mask variable. We could do mask equals tilde mask to invert it. Finally, use the bitwise AND operation to create a modified copy of the original data. So unsigned int result equals original data ampersand mask. That's using the bitwise AND operation to create a modified copy of the original data. So unsigned int result equals original data ampersand mask. So now all of the bits in the result variable are the same as their corresponding bits of original data, except the bits in digit 1 have been set to 0. The following diagram, a question mark is used to indicate that the value of that bit is the same in both variables. So all of these are the same, except for this. Future topic, negative numbers. So far we've discussed the representation of non-negative integer numbers only, 0 positive integers in a future class. We'll discuss how negative integers are represented. Sounds good. So arrays and vectors plus introduction to project 1. Got you. Arrays and vectors. Motivation for arrays. Suppose we wanted to write a program to store the highest temperature of the day for each day in the month of October. We could create 31 different variables, one for each day. Then we would need a switch statement to access the correct variable based on the current date. There must be a better way. It makes more sense to have the ability to group a large number of variables together, all having the same type. This is what arrays are for. An array is a type of data structure that stores variables of the same type in a contiguous chunk of memory. Each element in an array is assigned a unique subscript, also frequently called the index. Subscript start at 0. The last element's subscript is n-1, where n is the number of elements in the array. Declaring arrays, data type, name, bracket, size, where data type is any type, such as double or int. Name is the name of the array, and size is the number of elements in the array. For example, int sample data, bracket 5. Array elements. Each individual element in the array is called an array element. Our program can access the data in an array by using an array index, sometimes called a subscript. Array index, an integer between 0 and size -1. The syntax to access an array element is array name, bracket index. For the initial highest temperature example, we could define an array, double October high temp, bracket 31. So, okay. What index value to use? The first array element has an index value of 0. The last array element has an index value of array size -1. We need to keep this in mind when designing our programs. If our application deals with something that starts counting at 1, such as the day of the month, then we need to take care when setting the index. Array memory layout. Values are stored in adjacent memory locations. The definition int tests bracket 5 allocates the following memory for first element, second, third, fourth, and fifth element. Actual array size. The actual size of an array is the total number of bytes allocated for it. Number of elements times the bytes for each element. Examples, int test 5 has an actual size of 20 bytes, assuming 4 bytes for each int. Double values 10 has an actual size of 80 bytes, assuming 8 bytes for a double. Oops. Am I in the right place? Yeah, I am. Size declarators. Named constants are commonly used as size declarators, so const int size equals 5, int test size. This eases program maintenance if the size of the array needs to be changed at some time in the future. No automatic bounds checking in C++ arrays. When you use a value as an array subscript, C++ does not automatically check it to make sure it's a valid subscript. In other words, there is nothing in the language to protect you from using subscripts that are beyond the bounds of the array. This is a common source of bugs. Program logic must prevent array overflows. It is the programmer's responsibility to assure that the code does not use an invalid array subscript. Trying to access an array element outside the defined array boundaries can corrupt other memory locations, crash the program, or lock up the computer and cause elusive bugs. To prevent such errors, for example, use the same size constants to control array access loops as you use when defining the array, reading data from a file into an array. So in the textbook, there's a program that reads data from a file and saves it in an array. In this example, the name of the file is hard-coded into the program. Normally, a program would ask the user to specify the name of the input file. Care must be taken not to overflow the array. Maintain a counter of how many values have been read from the file so far. Make sure the counter does not exceed the array size. Similar sample program, read file to array, is available in my website for the class. One very interesting detail about this program is the way it controls the loop for reading data. Int count equals 0, while count is less than the array size. And input file exists, numbers, and input file is sending information to numbers count plus plus. The program relies on the fact that input file extraction operator numbers count will evaluate to true whenever the read operation is successful, but will evaluate to false if a read operation is not successful. That is, after the final number is read from the file, any additional attempts to read data will result in input file extraction numbers count evaluating to false. Writing array contents to a file. Program 7.8 copies the contents of an array into a data file. In this example, the name of the file is hard-coded into the program. Normally, a program would ask the user to specify the name of the output file. A similar sample program, write array to file CPP, is available on Moodle. So I'm going to go ahead and just save these because they're definitely going to be relevant for the project I'm working on. Arrays is function arguments. To pass an array to a function, just use the array name, show scores test to create a function that takes an array parameter. Use empty brackets in the function prototype and the function header. So void show scores int brackets, void show scores int test with brackets as the header. Save that too. Modifying arrays and functions. If a function parameter is an array name, and if the function modifies the contents of the array, then the function is actually modifying data that belongs to the caller of the function. Again, modifying arrays and functions. If a function parameter is an array name, and if the function modifies the contents of the array, then the function is actually modifying data that belongs to the caller of the function. Array names passed to functions are like reference variables. Changes made to the contents of an array in a function are reflected in the actual array, that is in data that belongs to the calling function. This can be a good thing if it is the desired behavior. However, the programmer of the code inside the function needs to exercise caution that an array is not inadvertently changed by the function. Array size as a function argument. When passing an array to a function, it is common also to pass the array size to that so that the function knows how many elements to process. So show scores, test, array size. Array size parameter must also be reflected in the function prototype and function header. Uncertain size of input data. Hold up real quick. Let's save this. Suppose we had to write a program to read data from an input file, and we know that the input file will contain between 1 and 100 integers. That is, on some days our input file may have 5 items, and on other days our input file may have 25 items, or any number up to 100. Our program needs to work for any size data file up to 100 integers without recompiling the code. How should we approach this task? Uncertain size of input data. One approach is to allocate enough space to handle the largest possible input file. In this example, the array contains 5 numbers, index 0 through index 4. The remaining array items are not currently in use. It may actually contain random garbage as data. Finding the highest value. Suppose we need to find the largest value and double my array size. Assume that the array may not be completely full. That means we need some variable that holds the number of elements that currently contain data, int number of elements. Create a variable to hold the largest value found so far, double largest so far. Start by assuming the element at index 0 holds the largest. So largest so far equals my array 0. Write a loop that compares an element in the array to the largest so far value. If an array element is larger than largest so far, then that value should become the new value of largest so far. So double largest so far equals my array 0. For int I equals 1, I less than number of elements. I plus plus, if my array I is greater than largest so far equals my array I. Why does I begin at 1 rather than 0? Because we don't need to compare the first element to itself. The range-based for loop. C++11 introduced a specialized version of the for loop that, in many circumstances, simplifies array processing. The range-based for loop executes the body of the loop once for each element in an array. Computer science people like to use the word iterate when they talk about executing the body of a loop. So they say a range-based for loop iterates once for each element of the array. The loop uses a range variable to hold the contents of the current element in the array. The range-based for loop automatically knows the number of elements in an array. You do not have to use a counter variable. You do not have to worry about stepping outside the bounds of the array. So the range-based for loop syntax is for data type range variable, array name, body of the loop in curly braces, where data type is the type of the range variable, and array elements. Range variable is the name of the range variable. Array name is the name of the array. Body of the loop executes for each iteration of the loop. The curly braces are required only if the body of the loop contains more than one statement. So in this example, we have int main, define an array of integers. Int numbers is 10, 20, 30, 40, 50. Display the numbers in the array for int val numbers. So essentially for int val in numbers, cout val and line. Modifying array contents. If you need your range-based for loop to modify the array contents, then you must make the loop variable a reference variable. Again, if you need your range-based for loop to modify the array contents, then you must make the loop variable a reference variable. So for int ampersand val in numbers, cout, enter an integer value, cin val. So let's save this stuff, right? So let's I don't think I saved this, but I will. I save this. int main constant size equals 5, int number size for int ampersand val colon numbers, cout enter an integer val, cin val, cout array contents, and line for int val in numbers, cout val in line. Range-based for loop limitations. If your program needs to use the array subscripts index values, then you cannot use a range-based for loop. For example, if the array is only partially populated, then your program needs to know the largest subscript for the portion of the array that is in use. In this case, use a regular for loop. Program needs to use the array subscripts index values, then you cannot use a range-based for loop. For example, if the array is only partially populated, right, then your program needs to know the largest subscript for the portion of the array that is in use. In this case, use a regular for loop. I don't know if that's going to matter for this project, but it might. Processing array contents. Individual array elements can be treated as ordinary variables of the same type as the array. When using plus plus minus minus operators, don't confuse the element with the subscript. So test I plus plus, add 1 to test I plus plus inside the brackets. So increment I, no effect on the contents of the array. Array assignment. To copy one array to another, don't try to assign one array to another. New test equals test won't work. Instead, copy the data element by element. So for int I equals 0, I less than array size, I plus plus, new test I equals test I. Damn it. It's not that deep, but for whatever reason, that was really annoying. Array assignment / copy. Printing a character array. You can display the contents of a character array by sending its name to cout. So suppose you initialize a character array like this, char greeting brackets equals hello. This results in a memory configuration like that. Now you can print the array contents to cout greeting and line, but this only works with character arrays, and the cout object expects the array contents to be a C string, null terminated. Printing the contents of an array. For arrays of a data type other than char, you must print element by element. For example, suppose you create this array, constant size equals 5, and test size equals curly braces 79, 82, and so on. Results in a memory configuration like that. And to print the array requires a loop. Constant array parameters. What if you want your function to be unable to modify the array contents? Void show values, const int nums, int size. Use the const modifier in the function prototype and header. Any code inside the function that attempts to modify the array contents will result in a compiler error. Conceptually, what we are doing here is asking the compiler to help us avoid making the mistake of modifying the contents of the array. Two-dimensional arrays, we can define one array. I guess I'll save this. I'm gonna have a bunch of slides in here, which is not what I wanted, but it's better than having to go through these and search for it. Two-dimensional arrays, we can define one array that conceptually arranges the data in rows and columns like a table in a spreadsheet. Use two size declarators in the array definition. Constant rows equals 4, calls equals 3. Int numbers, bracket rows, bracket calls. The first declarator is the number of rows, the second is the number of columns. And dimensional arrays. C++ does not limit the number of dimensions that an array can have. For example, const int rows equals 7, calls equals 5, layers equals 3. So you have a 3-dimensional array. Always use the simplest design that meets the requirements. Just because the language has a fancy feature does not mean that you must use that feature. Gotcha. Introduction to the STL vector. Data type defined in the standard template library can hold values of any type. So vector int scores. Automatically add space as more is needed. No need to determine size at definition. Can use brackets to access elements. Can hold values of any type. So declaring vectors, you must include vector. Declare a vector to hold int element. So vector int scores. Declare a vector with initial size 30. Vector int scores 30. Declare a vector and initialize all elements to 0. Vector int scores 30, 0. Declare a vector initialized to size and contents of another vector. So vector int final scores, adding elements to a vector. If you are using C++11, you can initialize a vector with a list of values. Vector int numbers 10, 20, 30, 40. Use pushback member function to add element to a full array or to an array that had no defined size. So scores.pushback 75. Again, it adds an element to a full array or to an array that had no defined size. Use size member function to determine size of a vector. So how big equals scores.size. Removing vector elements. Use popback member function to remove last element from a vector. Scores.popback. To remove all contents of a vector, use clear member function. Scores.clear. To determine if vector is empty, use empty member function, while not scores.empty, and so on. Other useful member functions: at description returns the value of the element at position I in the vector. So cout vec1.add I. Capacity returns the maximum number of elements a vector can store without allocating more memory. Max elements vec1.capacity. Reverse reverses the order of the elements in a vector. Vec1.reverse. Resize and val resizes the vector so it contains n elements. If new elements are added, they are initialized to val. Vec1.resize 50 and swap. Exchange the contents of two vectors. Vec1.swap vec2. So, okay, the rest of that isn't necessary for right now. So let's save all this info on vectors, right? We need 40 through 44. So now on to the next one. Still got a lot to go. Not even halfway through. But I'm going to go get some. What time is it? Oh, we're doing good. We're doing good. I'll be right back. So, searching and sorting arrays. Introduction to search algorithms. Search, locate an item in a list of information. Two algorithms we will examine: linear search, binary search. Linear search, also called the sequential search, starts at the first element, sequentially step through an array, examining each element until we locate the value we are searching for, the search target. If the end of the array is reached without a match, then the desired element is not present. Okay. Hope my highlighting helped that make sense to you. Linear search trade-offs. Benefits: easy algorithm to understand. Array can be in any order. Disadvantages: inefficient, slow for an array of n elements. Got you. Got you. So binary search, this algorithm requires the array elements to be in order, pre-sorted. One divides the array into 3 sections: middle element, elements on one side of the middle element, elements on the other side of the middle element. If the middle element is the target value, then the search is done. Otherwise, go to step 1, examining only the portion of the array that may contain the correct value. Continue steps 1 and 2 until either the value is found or there are no more elements to examine. So binary search example, we got this. So let's look at the code. Binary search benefit, much more efficient than linear search. For array of n elements, performs at most log base 2 n comparisons. Log base 2, expression log 2n is the number of times we would need to multiply 2 by itself in order to obtain the result n. For example, if n equals 256, log base 2 of n is 8 because 2 to the 8th power is 256. If n equals 512, log base 2 of n is 9 because 2 to the 9th power is 512. Binary search disadvantage. The disadvantage of using binary search is that it requires that array elements be sorted. So there's a sample program, introduction to sorting algorithms. Sort arranges values into an order, alphabetical, ascending numeric, descending numeric. 2 algorithms considered here, bubble sort and selection sort. So bubble sort, the concept, compare the first 2 elements. If out of order, exchange them to put in order. Compare the second and third elements, exchange if necessary. Continue comparing / exchanging adjacent elements until the end of array is reached. Pass through array again, exchanging is necessary. Repeat until one complete pass made with no exchanges. So again, conceptually right. We compare the first 2 elements. If they're out of order, exchange them to put in order. Then we compare the second and third elements, exchange if necessary. Keep doing that if necessary. And then we pass through again from the start, exchanging is necessary, and repeat until one complete pass made with no exchanges. So if we have 17, 5, 11, I'm going to sip, but let's look at this. Bubble sort trade-offs: benefit, easy to understand and implement; disadvantage, inefficient, slow for large arrays. Selection sort, concept for sort in ascending order. Locate smallest element in array, exchange it with element in position 0. Locate next smallest element in array, exchange it with the element in position 1. Continue until all elements are arranged in order. Selection sort example: array num list contains 11, 2, 29, 3. Smallest element is 2. Exchange 2 with the element in first position in array. Next smallest element is 3. Exchange 3 with the element in second position in array. Next smallest element is 11. Exchange 11 with element in third position of array. And we're good now. Selection sort trade-offs: benefits, sometimes more efficient than bubble sort, but not always. The selection sort algorithm usually performs fewer swaps because it moves items immediately to their final position in the array. Page 490. Disadvantage: so again, the selection sort algorithm usually performs fewer swaps because it moves items immediately to their final position in the array. Disadvantage: may not be as easy as bubble sort to understand. Curious observation: as the sample program is written in the chapter, and depending on the particular data in the array, there can be cases where the program swaps the data value with itself. Many different sorting algorithms, neither bubble sort nor selection sort, are among the most efficient sorting algorithms. If the number of items you need to sort is not very large, then any sorting algorithm is probably good enough as long as it gives the correct result. However, bubble sort and selection sort are good algorithms to learn first because they are relatively easy to understand. So cool, made it through the chapter. On to the next one, pointers. So, getting the address of a variable. Each variable in a program is stored at a unique memory address. Use address operator ampersand to get the memory address of a variable. So int numbers equals -99. Cout ampersand num prints the address in hexadecimal. As you recall, hexadecimal or hex is the name people use for base 16. Pointer holds an address. Pointer variable, often just called a pointer. It is a variable that holds an address. Because a pointer variable holds the address of another piece of data, it points to the data. Pointer variable syntax, definition, int ampersand int pointer. And again, right? Pointer variable, often just called a pointer, it is a variable that holds an address. Because a pointer variable holds the address of another piece of data, it points to the data. Pointer variable syntax, definition, int asterisk int pointer. Read as int pointer can hold the address of an int. Spacing in definition does not matter, so int space ampersand space int pointer is the same as above, and int ampersand space int pointer is the same as above. Pointer variable manipulation, assigning an address to a pointer variable. Int asterisk int pointer equals ampersand num. So what we're doing here, we're declaring our pointer int asterisk int pointer is a pointer that points to something, or it will point to something, and then we assign int pointer is equal to the reference, so the memory address of num. So now int pointer points to num. Memory layout, so num has the value 25, and int pointer holds the value of the memory location of num. The indirection operator. The indirection operator asterisk dereferences a pointer. It allows you to access the item that the pointer points to. So if we have int x equals 25 and int asterisk int pointer equals ampersand x, if we do cout asterisk int pointer and line will output 25. So if we did just int pointer, right, we'd get back the memory location of x. But when we use the asterisk, we're dereferencing it, and so it'll give us the value at this location, which is 25. Something like pointers arrays. We've already worked with something similar to pointers when we learned to pass arrays as arguments to functions. For example, suppose we need to pass the array numbers to the show values function. Const int size equals 5. Hold up real quick. Save this. So const int size equals 5, int number size, show values, number size. An array is a function parameter, so numbers array is this. The values parameter in the show values function points to the numbers array, so show values, numbers, size, so it takes the address, size, void show values, int size. C++ automatically stores the address of numbers in the values parameter. Reference variables as function parameters 1. We've also worked with something like pointers when we learned to use reference variables as function parameters. Suppose we have this function, void swap with ref params, int ampersand p1, int ampersand p2, int temp equals p1 equals p2 equals temp, and we call it with this code, swap with ref params number 1, number 2. After our program returns from the function, swap with ref params, the variables number 1 and number 2 will each contain the value originally in the other variable. This is because the swap with ref params function is actually working with the variables in the caller's environment. Pointer variables as function parameters 1. Suppose we have this function, void swap with pointer params, int asterisk p1 and int asterisk p2. Int temp equals asterisk p1 equals asterisk p2 equals temp. And call it with this code, swap with pointer params, ampersand number 3. So a reference to number 3 and a reference to number 4. And these get dereferenced. So we're actually messing with the real values after a program returns with a function. Swap with pointer params. The variables number 3 and number 4 will each contain the value originally in the other variable. This is because the swap with pointer params function dereferences the parameters in order to access the variables in the caller's environment. Wait, where'd the save go? So, a simple program, the relationship between arrays and pointers. Array name is starting address of the array. So int vals brackets equals 4, 7, 11. Starting address of vals is that. Count or cout vals will display its memory address, whereas cout val 0 will display 4. Array name can be used as a pointer constant. So if we have int vals bracket equals 4, 7, 11, cout dereferenced vals will display 4. Pointer can be used as an array name. So int asterisk val pointer equals vals, cout val pointer 1 will display 7. Pointers and expressions. Given int vals brackets equals 4, 7, 11, asterisk val pointer equals vals. What is val pointer plus 1? I would say it's the memory address. Yeah, it means address in val pointer plus 1 times size of an int. So cout dereference val pointer plus 1 displays 7, I see. And dereferenced val pointer plus 2 will display 11. Must use parentheses as shown in expressions. Why? This, I'm guessing, would do 6, I'm guessing. Because you're dereferencing it, which means you get 4, and you're adding 2. So array elements can be accessed in many ways. Array access method, array name in brackets, vals bracket 2 equals 17, pointer to an array in brackets, val pointer 2 equals 17, array name in subscript arithmetic, so dereferenced vals plus 2 equals 17, and pointer to array in subscript arithmetic, so val pointer plus 2 dereferenced equals 17. Array access conversion, vals I is equivalent to asterisk vals plus I. No automatic bounds checking performed on array access, whether using array name or pointer. Point arithmetic operations on pointer variables. So real quick. Operations on pointer variables. So I don't know if there's supposed to be something here, but int vals equals 4, 7, 11, int val pointer. So I'll say int asterisk val pointer equals vals. If we do this operation plus plus and minus minus, val pointer plus plus points at 7, val pointer minus minus now points at 4, plus and minus pointer and int cout. So this makes it point at 11, right? Plus equals val pointer equals vals, val pointer plus equals 2 now points to 11, minus pointer from pointer, cout val pointer minus val, difference number of ints between val pointer and val. Initializing pointers can initialize at definition time. Int num asterisk num pointer equals a reference to num. Int val 3 asterisk val pointer equals val. Cannot mix data types. Double cost int asterisk pointer equals ampersand cost. Won't work. Pointer integrity. How can you, let me just, how can your program know whether a pointer contains a valid address rather than random garbage? Always initialize pointers to null pointer if there is no other appropriate value. Verify that a pointer is not null pointer before using it. So if not pointer, if a valid pointer becomes invalid, set it to null pointer immediately. Comparing pointers, relational operators can be used to compare addresses in pointers. Comparing addresses in pointers is not the same as comparing contents pointed at by pointers. So this compares the addresses, this compares the contents. Real quick before I get too far from it, let me save this. Dynamic memory, we can allocate storage for a variable while program is running. Use the new operator to allocate memory, so double asterisk d pointer equals new double. New operation returns the address of the dynamically allocated memory. If we want to save this address in a variable, the type of that variable needs to be a pointer to the data type that we allocated. Dynamic memory allocation. We can also use the new operation to allocate an array. Int array size, double asterisk array pointer, cout, enter array size, cin array size, array pointer equals new double array size. That didn't sink in. Let's read it again from here. Dynamic memory. Apologies. We can allocate storage for a variable while program is running. Use the new operator to allocate memory. So if we do double asterisk d pointer, right? So it's going to be a pointer to a double. D pointer equals a new double. New operation returns the address of the dynamically allocated memory. So rather than declaring a separate double, we can just dynamically allocate that by doing new double. So returns the address of the dynamically allocated memory. If we want to save this address in a variable, the type of that variable needs to be a pointer to the data type that we allocated. Dynamic memory allocation. We can also use the new operation to allocate an array. So if we do int array size, double asterisk array pointer. So we're just creating a pointer that should point to something with a double data type. And then we do cout, enter array size, and then we do cin, whatever they enter gets sent to our array size integer variable. And then array pointer, we assign it new double array size. So we dynamically create this new array called double, and we fill it in with array size, and we send that to array pointer. Or maybe it's not called double, but that's how you say that it has the data. It's an array of doubles. We can then use our brackets or pointer arithmetic to access individual array elements. So for I equals 0, I less than array size, I plus plus, array pointer I equals I times I, or for I equals 0, I less than array size, I plus plus, dereferenced array pointer plus I equals I times I. Releasing dynamic memory. It is possible for a computer to run out of available memory. When our program no longer needs a particular segment of dynamically allocated memory, we should give it back. Use delete to free dynamic memory. Delete f pointer. Use brackets to free dynamic memory. So delete brackets array pointer. Only use delete with dynamic memory. After the dynamic memory has been released, set the pointer to null pointer. Memory leaks. The term memory leak is generally used to describe a situation where a program uses dynamic memory allocation to acquire some memory but never gives back the dynamically allocated memory after it is no longer needed. The problem of memory leaks is particularly challenging because it does not usually show up during initial debugging. For example, when you are testing your programming assignments for this course, you may not run your program long enough for a memory leak to be noticed unless you make a particular effort to test your program with large amounts of data. Returning pointers from functions. The return type of a function can be a pointer, int asterisk new num. The function must not return a pointer to a local variable in the function. A function should only return a pointer to data that was passed to the function as an argument or to dynamically allocated memory. If a function were to return a pointer to a local automatic variable, then the calling function cannot rely on the validity of the return pointer. Let me reread that. So returning pointers from functions. The return type of a function can be a pointer. If we do int asterisk new num as a function, we're declaring this function with a return type of a pointer. The function must not return a pointer to a local variable in the function. A function should only return a pointer to data that was passed to the function as an argument or to dynamically allocated memory. If a function were to return a pointer to a local automatic variable, then the calling function cannot rely on the validity of that return pointer. Got you. So let's what is this? 27, 28, 29. So this PDF. Good. Okay. Chapter 10, characters, C strings, and more about the string class. Character testing functions requires a CC type header file operate on one int parameter at a time. Recall a char is really a very small integer. So our function is alpha, meaning true if arg is a letter, false otherwise. Is alnum, true if arg is a letter or digit, false otherwise. Is digit, true if arg is a digit 0 through 9, false otherwise. Is lower, true if arg is lowercase letter, false otherwise. Is print, true if arg is a printable character, false otherwise. Is punct, true if arg is a punctuation character, false otherwise. Is upper, true if arg is an uppercase letter, false otherwise. And is space, true if arg is a white space character, false otherwise. Character case convention. Function to convert a single character to upper char. Function to convert a single character to lower char. Requires CC type header file. C strings obsolete. As we have already seen, the C++ language supports two kinds of strings, C strings and objects of the string class. While it is often more convenient to use string objects, it is still worthwhile to be familiar with the library functions related to C strings. C strings definition: C string, a sequence of characters stored in consecutive adjacent memory locations and terminated by null zero character. String literal, string constant, a sequence of characters enclosed in double quotes, like hi there. A string literal is stored in memory as a C string. C strings details: an array of chars can be used to define storage for string. Const int size equals 20, char city size. Leave room for the null character at the end of the string. Can enter a value using cn with the stream extraction operator. Input is white space. Terminated, no automatic check to see if enough space. For input that may contain white space, it is often better to use cn.getLine function. If your program uses both the stream extraction operator and getLine, then you should also use the cn.ignore function to avoid confusion with user prompts. This is discussed in chapter 3. So let's just write about we use getLine. Okay. Library functions for working with C strings require the C string header file. Functions take one or more C strings as arguments. Can use C string name, pointer to C string, literal string. Examples of C string functions: functions string length string returns length of a C string string. Char city size equals Missoula. C out string length city prints 8. And string cat string 1 string 2 append string to string 1. So char location size equals Missoula, comma space, char state 3 equals empty. String cat location state, location now has Missoula, empty. More C string function examples: functions string copy. Okay, I get it. These things do things. Finding a C string inside of string. It's important to finds the first occurrence of string 2 and string 1, returns a pointer to the beginning of the matching portion of string 1, or no pointer if no match is not found. It's important to recognize that the pointer returned may point to a C string that contains more characters in addition to the contents of string 2 search target. C string numeric conversion functions require C standard library header file. A to I converts C string to an int value, returns the value. A to L converts to long. A to F returns to a double. And I to A converts first int parameter to a C string, stores it in the second parameter. Third parameter is base of converted value. C string numeric conversion functions notes: if a C string contains non-digits, the results of the C string conversion functions are undefined by C++. Function may return results up to non-digit. Function may return 0. The result in a situation like this is sometimes called implementation dependent. It depends on which compiler you're using. I to A does no bounds checking. Make sure there is enough space to store the result. Writing your own C string handling functions. If none of the C string library functions meet your needs, you can write your own functions. Designing C string handling functions can pass arrays or pointers to char arrays, can perform bounds checking to ensure enough space for results, can anticipate unexpected user input. More about the C++ string class. C++ string class, we have already discussed various details about how we can use objects with the string class, so some of this material is review. The string class defines a special data type that supports working with text. To use the string class, you must use the library definitions, include string, can define string variables in programs like that, can define values, can be used to be displayed, input into a string object. If you use the stream extraction operator for input to a string object, be aware that it uses white space as separators. The stream extraction operator will stop reading when it encounters a white space character in the input data. Use the getLine function to read a line of input, possibly including spaces, to a string. String address, cout, enter your address, getLine, cin, address. String comparison, the string class allows you to use relational operators directly to compare string objects. So, yep, the comparison is based, yep. String literal is always represented in memory by a null terminated C string. The string class, several operators. This references character in a string using array notation, good to know. So examples, gotcha, string member functions. In addition to the operator overloaded functions, there are many functions with descriptive names, categories, assignment, assign, copy, data, modification, append, clear, erase, insert, replace, swap, space management, capacity, capacity, empty, length, resize, size, substrings, find, substring, comparison, compare. More examples in the example below. Suppose the user enters the text hot, so the word 1 variable contains the contents. String word 1, word 2, phrase. In word 1, user enters hot, word 2 dot assign dog, phrase dot append word 1, phrase dot append word 2, phrase as hot dog, phrase dot append with mustard relish, and so on. Insert at 8 on a bun, you're inserting into 0, 1, 2, 3, 4, 5, 6, 7, 8. Maybe it's one index, I'm not sure, but hot dog on a bun with mustard, right? Makes sense. Converting a string object to a number. STOI, string accepts a string argument and returns that argument's value converted to an int. STOL, string. So this is, I'll just save this. Converting a number to a string. Generating the equivalent C string. Some library functions may require that you pass an argument that is a C string. It's easy to convert a string object to its equivalent C string. If we do string sample equals sample text, char asterisk equivalent equals sample.c string. The find function, suppose my string is an object of the string class, and we need to find the position of a particular string within my string. My string.find string x returns the first position at or beyond position x, where the string is found in my string. The target string may be either a string object or a character array. We could also search for a single character. Returns the first position at or beyond position x, where z is found in my string. Substrings. A substring is a string that is part of another string. Suppose my string is an object of the string class containing the first 10 letters of the alphabet. So string, my string equals that. If we want to obtain a substring of my string starting at index 3 and continuing for a length of 5 characters, then the text in the resulting substring is DEFGH. We would use my string.substring xn. So in this case, we do returns a newly constructed string object. The new string contents are copied from the myString object starting at index x. So 0, 1, 2, 3, we do 3, and starting at index x with length of 5, so it would be 3, 5, yeah. Fields within a string. There are many occasions when a particular string object contains text that has multiple fields. The fields in the string may be separated by a special character called a delimiter. For example, if a string contains the text representation of a date, it might look like the following: 3-22-2018. In this example, the delimiter character is the dash, and the 3 fields are 3, 22, and 2018. The actual calendar date represented by the string is March 22nd, 2018. Split line to array, so it reads a text file one line at a time, called split line to array function for each line of text. Outputs to console and output file. The fields from each line of input file. Uses string class functions. Find, search for a character within a string object. Substring, return a copy of part of a string object. Studying split line to array. When you are studying the split line to array function, refer to that in the textbook. So sample data file, first 10 dates.txt with a field delimiter character of a pipe. You have Washington, comma, George, pipe 1789, pipe 1797, and Adams, comma, John, pipe 1797, pipe 1801, and so on. Sample data file, colleges.txt, a field delimiter character, so, and then a lab. So what I'm gonna do is I'm gonna save this just because this is like literally part of the project that I'm working on. Fields within a string. So what's that? This is 30 to 35. Making progress, making progress. I'm gonna go get a little bit more coffee. What's good, what's good? It's always sad when I save like barely 2 sips of coffee for the end. You know, you wanna get like a satisfying last dose of your drug of choice. Just gonna make it stretch. Another thing that sucks about finishing the coffee is I can no longer use it to take a break, right? So we're just gonna have to power through this. Let's do it though. So, chapter 11, structured data. Representing data in C++, C++ primitive data types. You have bool, int, char, long int, all the normal stuff. With our operations, we can also group variables together as arrays of the primitive data types. The array subscript index is used to access individual elements of an array. All the elements in an array must have the same data type. Data of different types. What if we want to store data of different types? Imagine a program that needs to store information about all students at a college. What kind of data will we need? Need integers for the student ID, strings, first name, last name, etc. Doubles for grade point average. We could use a different array for each data item. All of the information for a particular student will be contained in all of the arrays, but in one particular subscript index value. Parallel arrays. Corresponding elements with the same subscript value are logically related to each other. The program must take care not to mix up the array subscripts. Use the same subscript value when accessing the different arrays to avoid confusing the data. The next slide illustrates a hypothetical example where parallel arrays are used to represent data from multiple students at a college. If the array index values get confused, then the software could wind up displaying the wrong GPA value for a particular student. Hypothetical example of parallel arrays would be these 6 or these 5 arrays. Note these names are chosen. Combining data into structures. A structure, C++ construct that allows multiple variables of different data types to be grouped together. General format, struct name, brackets, type 1, field 1, type 2, field 2, and so on. Better than using parallel arrays. If we have struct student, int student ID, string first name, string last name, double GPA, string major. So student here is the structure tag, and all of these are the structure members. Student, student 1, student, all students, 1000. So yeah, you're just declaring a student 1, which is a student object, more structure, and we're declaring another student object with we're saying all students 1,000, so an array of students that has 1,000 members. Accessing structure members. I shouldn't use the word member there. That's weird. 1,000 elements, I guess you could say. Accessing structure members. Variable name dot member name. For example, student one dot major equals engineering. Cout student. Student one dot first name. So in this case, we're assigning engineering to student one's major. We can do cout, send student to cout, and then we can output student one dot first name, blank space, student one dot last name has a new major, and student one dot major and line. Working with structure variables, comparing the contents of two structure variables must be done one member at a time. So this is wrong. If student one is equal to all students 25, no, we don't do that. We do if student one dot student ID is equal to all students 25 dot student ID. And again, when working with structure variables, comparing the contents of two structure variables must be done one member at a time. Passing struct data to a function may pass individual members of a struct as arguments to functions. We can do display major, student one dot major may pass entire struct variable to a function. We can do show data student one. If a function needs to modify contents of a structure variable, pass the variable by reference. So void calculate GPA student ampersand s. We can do s.gpa equals some value. So structure as function argument, struct rectangle, these definitions, void show rectangle, rectangle R is the prototype. In our main function, rectangle is a box. We set up its length and width, and then we do box.area is its length times its width. And then we have this show rect, which we pass box. Structure, so void show rect, rectangle R. So the show rect function is expecting to take in a rectangle structure and output its length, width, and area. Copies the caller's variable into the function's local memory, right? That's what's happening when we okay, so just when you pass a structure as a function argument, like we're doing right here, we're copying the caller's variable into the function's local memory. So copying box into this function's local memory. If the struct has many fields, this could be a lot of copying. Structures as function arguments. Using value parameter for structure makes a copy of the struct as a local variable inside the function. This can slow down a program, waste memory. Using a reference parameter will speed up program less data to copy, but then the function could change data inside the structure. That's okay if it's what you want, but what if you would prefer to prevent it? Const function parameters. Using a const reference parameter allows the function read-only access to reference parameter, but does not waste space or speed. Again, using a const reference parameter allows the function read-only access to reference parameter, but does not waste space or speed. As a modification of the previous example, a version of showRect which cannot modify the caller's data, so we would do void showRect const rectangle ampersand R. So now we can read directly from whatever we pass it without having to copy another one, but we won't be able to write to it or edit it. Nested structures. A structure can contain another structure as a member. So struct personal info, string name, address, city, struct employee, int employee ID, personal info, p data, short year joined company, double weekly salary. Members of nested structures use the dot operator multiple times to refer to fields of nested structures. So employee, employee one, we do employee p data dot name to access the name, and similar for city. Returning a structure from a function. A function can return a struct employee input employee info. It's a prototype employee typical employee local variable. Typical employee equals input employee info. So again, returning a structure from a function. Function can return a struct. So we define this function input employee info and expect it to return an employee struct. And then we do employee typical employee. So that's defining an employee object or an employee structure. And then we assign typical employee equals employee info. So that's a function where we're going to create and populate the members for this typical employee. The function must define a local internal variable to hold data values. So employee E1 would exist inside that function. The function returns the struct to the caller. So here we see employee input employee info define employee E1, cout enter employee data and line, cout employee ID, cin E1.employee ID, cin.ignore 10 new line, cout employee name, get line cin E1.pdata.name, cout employee address, get line cin E1.pdata.address, city, get line, year hired, cin E1.year joined company, cout weekly salary, cin E1.weekly salary, return the struct to the caller, so we're going to return E1, and then we end that function. Pointers to structures, as we have already seen, if our program declares a struct student, string name, int id num, int credit hours, double GPA, then we can define a variable of that type, so student freshman. And again, we've declared a struct and we can define a variable of that type. We can also use the ampersand operator to obtain the memory address of that variable, so student asterisk student pointer, so we're declaring an object that's meant to point to, or we're declaring a variable that's meant to point to a student structure, and we're assigning that a reference to freshman. We can use the ampersand operator to obtain the memory address of that variable. A structure pointer can be a function parameter. See also that, so pointer struct demo. So we would do this, we'd create this student structure and then have this function void get data student asterisk. So it's expecting to, this get data function is expecting to take a pointer to a student object, rather than, it'd be one thing if it was expecting to take a student object itself, that would be passing the object. But in this case, we're expecting a pointer to it, so we're expecting a memory location valued variable. Int main student ID, in main student freshman, get data, so we're passing a reference to freshman, so it's a pointer to freshman rather than just freshman. Pointer to struct, so void get data student asterisk s, get the student name, so cout student name, get line cin s name, so it's kind of like name or s dot name, but in this case we're doing s pointing to name. Get the student ID number, cout student ID number, cin s point to ID number. Get the credit hours and roles, so similar s pointing to credit hours and s pointer to GPA. Pointer access to structure members must use parentheses to dereference a pointer to the structure. Cout stream insertion parentheses, so dereferencing student pointer to ID num. Why? Because the dot operator has a higher precedence than the unary asterisk operator. So if you didn't use the parentheses, it would think that you're trying to dereference student pointer to ID num. But in this case, we're dereferencing student pointer. So instead of getting the memory location, we're getting the object at that memory location, and then we're getting the ID number associated with this object. An equivalent syntax involves using the structure pointer operator to eliminate the parentheses and provide clear notation. So again, this is doing the same thing. We're getting the item at this memory location. Rather than just trying to access the ID number of the memory location, we're accessing the ID number of the object at that memory location with this student pointer pointing to ID num. This is a lab. Okay, cool, made it to the chat. It's funny how I get on here and start talking different. Like, I've never used the word chap in my life. Oh, it's funny. Okay, chapter 13, Introduction to Classes, part 1. Let's do it. So, what's the big deal about object-oriented programming? This sort of programming we have done up to now is called procedural programming, sometimes called modular programming. We write our code, group it into modules, functions, so we can reuse portions of it, and it seems to work. So why do we need OOP? For very small programs written by only one person, very often we do not really need OOP. But as systems become larger and more complex, with many programmers on a project team, traditional procedural programming methods become more difficult to get right. Abstract data type ADT, created by the programmer, composed of one or more primitive data types or other abstract data types, may include a defined set of operations. Abstract data type example, Let us define a data type, which we will call date. A date value contains three primitive data type. Let us define a data type, which we will call date. A date value contains three primitive data members. Month, integer from 1 to 12. Day, integer from 1 to month length, where month length is 1 of 28, 29, 30, or 31. Year is an integer. Textual representation, one of many, like so. Representing an abstract data type in C++. What if we use a struct? We would do struct date, int month, int day, int year. Date this day.month is 3. This day.date is 25. This day dot year is 2013. Operations on the date ADT. Let's define several operations on date. Increment. So we could increment 03/25/2013, and result would be 03/26/2013. We could increment 01/31/2012. Result is 02/01/2012. Decrement is similar. Interval D1, D2, number of days between two dates. Next week, D1, the date value of D1 plus 7 days. So next week, 03/25/2013. Result is 04/01/2013. Operations such as these are implemented using C++ functions. Abstraction and data types. Abstraction, a definition that captures general characteristics without necessarily specifying all of the details. Data type defines the values that can be stored in a variable and the operations that can be performed on it. The user of an abstract data type, that is the person who writes the calling program, does not need to know the details of how the data is stored or how the operations are implemented. Comparing procedural and object-oriented programming. Procedural programming focuses on the process/actions that occur in a program. In a large procedural program, often large amounts of data are defined in a central location, and there are many sections of the code that might modify any one portion of the data. An object-oriented program is designed in a somewhat different way. The programmer thinks about 1. The data that will represent some real-world object, and 2. The fundamental operations that need to be performed on that data. The programmer constructs the overall program by using those fundamental operations. Limitations of procedural programming. If the data structures change in a large system that uses procedural programming, often many functions must also be changed. Programs that are based on complex function hierarchies can be difficult to understand and maintain, difficult to modify and extend, difficult to avoid creating new bugs during enhancement efforts. These problems are especially difficult if a project has many programmers, if the programming team is spread across a wide geographic area. Object-oriented programming terminology. Class, like a struct, allows bundling of related variables, but also logically groups the functions code with the data. Object, an instance of a class, in the same way that a variable can be an instance of a struct. Classes and objects. A class is like a blueprint, and objects are like houses built from the blueprint. Key concepts to remember: an object is an instance of a class. Everyday examples: Boston is an instance of a city. The Boston Red Sox is an instance of a baseball team. Fenway Park is an instance of a stadium. Bunker Hill Community College is an instance of a college. CSE 237 is an instance of a course. More terminology and concepts. Terminology: attributes, member variables of a class. Methods or behaviors, member functions of a class. Concepts: encapsulation refers to the combining of data and code into a single object. Data hiding refers to the ability to restrict access to certain members of an object. Public interface, members of an object that are accessible to code outside of the object. These concepts allow the object to provide access to some data and functions without sharing its internal details and design, and provide some protection from data corruption by code that is outside the class. Declaring a class. In C++, we can use a class to implement an abstract data type ADT. Objects are created from a class. C++ syntax: class, class name, declaration, declaration. Again, declaring a class. In C++, we can use a class to implement an abstract data type. Objects are created from a class, and the syntax is class, class name, declaration, declaration, in curly braces. Example: so we have class rectangle, curly braces, private, double width, double length, public, void, set width, double, void, set length, double, double get width, const, double get length, const, double get area, const. Access specifiers, used to control access to members of the class. Public can be accessed by functions outside of the class. Private can only be called by or accessed by functions that are members of the class. Can be listed in any order in a class. Can appear multiple times in a class. If not specified, the default is private. Class examples: we have this class rectangle with the private members, double width and double length. and its public members are void set width double, void set length double, double get width const, double get length const, double get area const. Using const with member functions, const appearing after the parentheses in a member function declaration specifies that the function will not change any data in the object itself. Double get width const, and so on. Declaring defining a member function. Function declaration, put the function prototype inside the class declaration between the curly braces that follow the class keyword. Again, function declaration, put the function prototype inside the class declaration between the curly braces that follow the class keyword. Function definition, the actual code for the function is usually outside the class declaration. Place the class name and scope resolution operator, double colons, immediately before the function name. So void rectangle scope resolution operator, double colons, and then the function name set width, double W, and then the stuff that the function is going to do, like width equals W. Accessors and mutators, or getters and setters. Accessor, function that retrieves a value from a private member variable. Accessors do not change an object's data, so they should be marked const. Mutator, a member function that stores a value in a private member variable or changes its value in some way. Defining an instance of a class. An object is an instance of a class defined like structure variables, so rectangle R. Access members using the dot operator, so R dot set width, 5.2, cout R dot get width. Compiler error if attempt to access private member from code outside the class using the dot operator. So this class declaration, rectangle, same idea. We have this void rectangle, and this is called the scope resolution operator. So when this is the class declaration, and then separate from this, void rectangle, I forgot it again, scope operator, scope resolution operator. So void rectangle colon for the scope resolution operator, set width double W, width equals W. Void rectangle scope resolution operator colon set length double len, length equals len. Double rectangle scope resolution operator colon get width const, return the width. Double rectangle colon get length const, return length. And double rectangle colon get area const, return width times length. Our main function, we do rectangle box, define a rectangle instance. Double rect width and rect length are local variables. See out what is the width and send the width to the rect width. What is the length? Send the user input to the rect length. Box.set width, pass rect width. Box.set length, pass rect length. And then we're going to output the width. So box.get width and line. Output the length, box.get length and line. Output the area, box.get area and line. Multiple objects of the same class. Program 3.2 reuses the rectangle class, creates 3 rectangle objects, so a kitchen, a bedroom, and a den. Each of these objects has its own private length and width variables. After setting the length and width values for all 3 objects, the program calculates the total area. So total area equals kitchen.getArea plus bedroom.getArea plus den.getArea. A member function to operate on multiple objects. Suppose we wish to add a new function to the rectangle class called total area. The total area function calculates the area of 2 rectangles, the current object and another object, returning the total area to the caller. The function prototype could be double total area rectangle reference, so rectangle ampersand. This is expecting to pass a reference to a rectangle. Const example function total area, so the current object does not need a calling parameter. Double rectangle double colon total area rectangle ampersand rect. So it's expecting to be passed a reference to a rectangle object. Return get area. So you're calling get area plus rect dot get area. So you're calling get area on the current rectangle, and you're adding a get area on the input rectangle. A program that uses the total area function might have 2 rectangle objects, rectangle R1, rectangle or just R2. We say that object R1 invokes the function, passing a reference to object R2 as the argument. R1.totalArea, R2. Sample program, rectangle total area. So a simple program, avoiding stale data. Some data is the result of a calculation. In the rectangle class, the getArea function recalculates the area value whenever it is needed. Double rectangle, getArea const, return width times length. If we were to redesign the rectangle class to use an area variable, its value would be dependent on the length and the width values. Then if we were to change length or width without updating area, then area would become stale, out of date. To avoid stale data, it is usually best to recalculate the value of dependent data within a member function rather than store it in a member variable. Why have private members? Making data members private provides data protection. From outside the class, private member variables can be accessed only through public functions. Public functions define the class's public interface. Public interface code outside the class must use the class's public member functions to interact with the object. So we have this rectangle class, the width and length are private, and the code outside the class has to interact with our public member functions to interact with the object. Abstract data type formal definition, a mathematical model which may be used to capture the essentials of a problem domain in order to translate it into a computer program. Examples include queues, lists, stacks, trees, graphs, and sets. Do not let the fancy words intimidate you. ADT, abstract data type, is a useful concept which can help you design and understand programs, but it does not need to be difficult to understand. So summary, abstract data type, ADT, created from other data types, includes operations on the data. A class similar to abstract data type specifies data members and member functions. Data members usually private, member functions usually public, and object is an instance of a class. Nice. 13.2 Introduction to Classes Part 2. So, example class specification, right? Example class implementation, makes sense. Invocation, we've seen this. In place member initialization. Question: can we define initial values for member variables? Class rectangle private double width equals 0, double length. Is this okay? Answer yes if your compiler allows it. Prior to the C++ 11 version of the language, this was not supported. Object initialization. In general, how do you initialize an object? Use a special function called a constructor. Class rectangle private double width, double length, public rectangle, that's the constructor. A constructor function, a member function that is automatically called when an object is created. Its purpose is to initialize the object. The constructor function name is always the same as the class name, has no return type. Let me read that again. A constructor function is a member function that is automatically called when an object is created. Its purpose is to initialize the object. The constructor function name is always the same as the class name. Has no return type. So our example, rectangle, double colon, rectangle, width equals 0, length equals 0. Overloading constructors. A class can have more than one constructor. That is, we can write one or more overloaded constructors as part of the class. Overloaded constructors in the same class must have different signatures. That is, the data types of the parameter list must be different for each overloaded constructor. So we could do rectangle with an empty parameter list. We could do rectangle double. We could do rectangle double double. Default constructor. A default constructor is a constructor that can be invoked without an argument list. Either the constructor has no arguments or all of the arguments have default values. If you write a class with no constructor at all, C++ will create a default constructor for you. This automatically generated default constructor will take no arguments. The automatically generated default constructor does not contain any code. Simple object instantiation. A simple instantiation of a class with no arguments calls the default constructor. So rectangle R, again, is a simple object instantiation. A simple instantiation of a class with no arguments calls the default constructor. Constructor with arguments. To create a constructor that takes arguments, indicate, hold on. Create a constructor that takes arguments, indicate parameter types and prototypes. So rectangle double double, use parameters in the definition. Rectangle colon colon, rectangle double W, double len, width equals W, length equals len. Passing arguments to constructors. You can pass arguments to the constructor when you create an object. So we can do rectangle R and pass it 5 and 10. More about default constructors. If all of a constructor's parameters have default arguments, then it is a default constructor. For example, rectangle double equals 0, double equals 0. Again, if all of a constructor's parameters have default arguments, then it is a default constructor. For example, that. Creating an object and passing no arguments will cause this constructor to execute. Rectangle R. Classes with no default constructor. If you write a class that includes one or more constructors and all of the class's constructors require arguments, then the class has no default constructor. Again, if you write a class that includes one or more constructors and all of the class's constructors require arguments, the class has no default constructor. When this is the case, you must pass the required arguments to the constructor whenever creating an object of this class. If this is a problem, then it's easy enough for the programmer to write another constructor that will be the default constructor. Destructors. Member function automatically called when an object is destroyed. Destructor name is tilde class name. For example, tilde rectangle has no return type, takes no arguments. Only one destructor can exist per class, i.e. it cannot be overloaded. If a constructor allocates dynamic memory, destructor should release it. If a class has no explicitly declared destructor, then it is considered to have a destructor that does nothing. Only one default constructor and one destructor. Do not provide more than one default constructor for a class, one that takes no arguments and one that has default arguments for all parameters. So if you do square with no arguments and square int equals 0, it will not compile. Since the destructor takes no arguments, there can only be one destructor for a class. Constructors, destructors, and dynamically allocated objects. When an object is dynamically allocated with the new operator, its constructor executes. So if we do rectangle asterisk r equals a new rectangle, so 10 to 1020. So we're doing in this case, right, we're declaring a pointer. So rectangle asterisk r means we want to point to a rectangle object. And in this, we're going to save a new rectangle, which we're passing the values of 10 and 20. When the object is destroyed, its destructor executes. So when we do delete r, it runs our destructor, which is tilde rectangle. Memory management to prevent memory leaks. Unreferenced dynamically allocated memory. There must be a one-to-one correspondence between allocation and deallocation. If a constructor allocates memory, then usually the destructor for that class should deallocate it. The programmer should have a clear idea of what dynamically allocated memory is owned by a particular object. The destructor function is a good place to be sure the program deallocates memory. Member function overloading. Non-constructor member functions can also be overloaded. So void set cost double, void set cost char asterisk. And again, non-constructor member functions can also be overloaded. Each overloaded member function must have a unique parameter list, unique signature. Using private member functions. A private member function can only be called by another member function in this class. It is used for internal processing by code that is inside this class, not for use by code outside of the class. Imagine any operation that is needed for code inside the class, but for whatever reason, the designer of the class does not want any code from outside the class calling this function. Inline member functions. Most often, member functions are declared inside the class declaration as a function prototype. Hold on, let me let this sink in. Using private member functions. A private member function can only be called by another member function in this class. It is used for internal processing by code that is inside this class, not for use by code outside of the class. Imagine any operation that is needed for code inside the class, but for whatever reason, the designer of the class does not want any code from outside the class calling this function. Then we have inline member functions. Most often, member functions are declared inside the class declaration as a function prototype, defined outside the class declaration, either in the same file or another file. Member functions can also be defined inside the class declaration if the entire function is provided inside the class declaration, not just the function prototype, then this is considered an inline function. Inline functions are most appropriate for functions that did not have many statements in the function body. For example, int get width, const return width. Class with inline member functions. So we have class rectangle with inline functions, private double width length, public void set width double, void set length double, double get width const return width, double get length const return length, double get area const return width times length. Trade-offs: inline versus regular member functions. Regular functions, when called, compiler stores return address of call, allocates memory for local variables, etc. There is some amount of runtime overhead associated with a regular function call. With an inline function, the actual code for the function is copied into the executable file inline. There's no real code in the executable file for calling the function or setting up its local environment. This results in faster execution of the program. This also results in a larger executable file. The unified modeling language, When people design complex systems, they often like to produce diagrams of the classes that they are planning to create. Members of a programming team need to discuss the design even before they write any code. To facilitate sharing and discussing a design with other people, the industry has defined a standard for class diagrams. UML stands for Unified Modeling Language. The UML provides a set of standard diagrams for graphically depicting object-oriented systems. UML class diagram. A UML diagram for a class has up to 3 main sections. Class name goes there, member variables are listed there, and member functions are listed there. Example, a rectangle class. So this class would do rectangle width, length, and set with all the functions. Again, member variables there, member functions are there. UML class specification notation. In UML, you indicate a private member with a minus and a public member with a plus. These member variables are private. These member functions are public. UML data type notation. To indicate the data type of a member variable, place a colon followed by the name of the data type after the name of the variable. Again, to indicate the data type of a member variable, place a colon followed by the name of the data type after the name of the variable. So minus with colon double lets you know we have a private width variable that has a data type of double. UML parameter type notation. To indicate the data type of function's parameter variable, place a colon followed by the name of the data type after the name of the variable. So we'd have this public set width function with a width of a type double, or we'll just say double W colon double. To indicate the data type of a function's parameter variable, place a colon followed by the name of the data type after the name of the variable. UML function return type notation. To indicate the data type of function's return value, place a colon followed by the name of the data type after the function's parameter list, like so. Separating the class specification from the class implementation. Place class declaration in a header file that serves as a class specification file named classname.h. For example, rectangle.h. Place member function definitions, the actual code, in a class implementation file named classname.cpp. For example, rectangle.cpp. The implementation file must have a hashtag include statement for the class specification file. Again, the implementation file, the .cpp file, must have a pound include statement for the class specification file, the header.h. Programs that use the class must also have a pound include statement for the class specification file, the header. Programs that use the class must be linked with the actual code for the class. More about this later, but again, programs that use the class must be linked with the actual code for the class. So there's a sample program in my textbook. The textbook has a sample program, and I have a copy of it. Remember how C++ builds tools work? We type our code into an application program known as an integrated development environment, an IDE. An IDE is an example of a special category of computer program software tools, common IDE programs. When we click on the build command in the IDE, it runs the compiler tools. C++ compiler tools include a preprocessor, a compiler, and a linker. So again, source code is entered with a text editor by the programmer into the source code, goes through a preprocessor. You get the modified source code, which goes through a compiler. You get the object code, which goes through the linker, and you get the executable code. Familiar preprocessor directives. We've seen the use of several preprocessor directives. Pound include IOStream, include library definitions. Pound define pi 3.14159. Define a constant. Note this is not the best way to define a constant. Include guard directives. Conditional inclusion of text. So pound if and def. Rectangle h. Pound define rectangle h. Header file contents. Class declaration plus any other defined statements. Pound and if. This assures that the header file contents can only be executed once, that is, after the first include operation declares the class. Any additional inclusions will be ignored. And then I had a lab that I did, so call this guard directives, and okay, what is this, 33 through 37. Okay, cool. Making good progress. Chapter 14, more about classes. What time is it? 9:35. Okay, good. More about classes. Recall example from earlier lecture. It is possible for a program. Let me take some water real quick. So recall example from earlier lecture. It is possible for a program to contain more than one object instance of a particular class. Program 13.2 creates 3 objects instances of the rectangle class. Kitchen is a rectangle, bedroom is a rectangle, den is a rectangle. After setting the length with values for each of the 3 objects, the program calculates the total area. Total area equals kitchen.get area plus bedroom.get area plus den.get area. Each of these objects has its own private length and width variables, instance and static members. For any situation where each object of the class has its own value for some attribute, we use an instance variable to represent it. Instance variable, a member variable in a class. Each object has its own copy. Sometimes, however, a class needs to have only one value for all objects of the class. Static variable, one variable shared among all objects of a class. If a static variable is private, then there needs to be some way for code outside the class to access that data. Static member function can be used to access a static member variable. It can be called before any objects are defined. Declaring a static member variable. The static variable is declared inside the class specification. So we have class tree with private static int object count. That's declaring the static member variable object count. Public tree object count plus plus static int get object count return object count. However, the static variable must be defined, created outside the class specification. So what's happening here? The static variable is declared inside the class specification. So class tree, which has a private static int object count, and then public tree constructor, which seems to increment the count. So every time the object is called, we increment object count, and we have this static int get object count, which returns the object count. And again, coming back here, let's so sometimes a class, so I'll read it from the top. Instance and static members. For any situation where each object of the class has its own value for some attribute, we use an instance variable to represent it. Instance variable, a member variable in a class. Each object has its own copy. Sometimes, however, a class needs to have only one value for all objects of the class. Static variable, one variable shared among all objects of a class. If a static variable is private, then there needs to be some way for code outside the class to access that data. Static member function can be used to access a static member variable. Can be called before any objects are defined. And again, the static variable is declared inside the class specification. So we have this class tree, private, a static int object count, public tree constructor, which increments the object count, and then this static int get object count, which returns the object count. However, the static variable must be defined, created outside the class specification. Defining a static member variable. The definition of the static member variable is outside the class specification. Int tree double colon, so object count equals 0. This definition statement causes the variable to be created in memory. Unlike an instance variable, a static variable exists before any objects of the class are created. Calling a static member function declared with static before return type, so static int get object count return object count. Again, calling a static member function declared with static before return type. Static int get object count returns object count. Can be called independent of objects, so int num equals tree double colon get object count. Using the tree class, int main define 3 tree objects: tree oak, tree elm, tree pine. Display number of tree objects. See out, we have pine.get object count tree objects return 0. In this example, we create 3 objects of the tree class, but there is only one call to get object count using an existing object. However, we could call get object count using the same name. However, we could call get object count using the class name. 3 instances of the tree class, but only one object count variable. Object count variable is static. Instances of the tree class, see that. So this pointer, this a predefined pointer available to a class's member functions It always points to the instance object of the class whose function is being called. It is passed as a hidden argument to all non-static member functions. It can be used to access members that may be hidden by function parameters with the same name. So this pointer example, we have class, some class, private int num, public void set num, int num, this num equals num. Perfectly reasonable question. Why wouldn't the programmer just use some other name for the function parameter so the class variable will not be hidden? Answer: very often programmers do exactly that, but in case that is inconvenient, the language does provide this mechanism to resolve the conflict. So let's read that again. The this pointer. This, a predefined pointer available to a class's member functions. It always points to the instance object of the class whose function is being called. It is passed as a hidden argument to all non-static member functions. It can be used to access members that may be hidden by function parameters with the same name. So this is an example. So we do class, some class, private int num, public void set num, which takes an int num, which is this, and then we do this num equals num. And why wouldn't the programmer just use some other name for the function parameter? So the class variable would not be hidden. And we, programmers often do that, but in case that's inconvenient, language provides this mechanism to resolve the conflict. Assignment versus initialization. Assignment occurs between two objects that already exist. Initialization happens to an object at the time it is being created. See the modified version of that member-wise assignment demo. Member-wise assignment. In general, we can use the assignment operator equals to assign one object to another, or to initialize a new object with another object's data. Copies member to member. For example, box 2 equals box 1 means copy all member values from box 1 object and assign the values to the corresponding member variables of the box 2. If we use this syntax to initialize an object, then it is actually calling a special constructor function called the copy constructor. Rectangle box 3 equals box 2. Copy constructors. Special constructor used when a newly created object is initialized to the data of another object of same class. The default copy constructor copies field to field, member-wise assignment. The default copy constructor works fine in many cases, but sometimes a programmer needs to write their own copy constructor. Caution, the next several slides contain code that was not fully tested. For an equivalent tested example, refer to this sample code. Okay, good to know. Dynamically allocated member data. Problem, what if object contains a pointer? Give me 1 second. So, dynamically allocated member data. Problem. What if object contains a pointer? Class, some class, public, some class, int val equals 0, value equals new int. So we're dynamically creating a new integer and assigning that to value. And then we're assigning the input val to value. So if we were just, but value is a pointer. Okay. Int get val, void, set val int, private int, asterisk value. So our object 1 value points to 5. This is confusing. So what if object contains a pointer? Some class. The way it's written also is just annoying. But anyway, so some class. So this is a constructor. The default value 0, and the value is a new integer, and asterisk value equals val, int get val, void set val int, private int asterisk value. This is confusing me. Step 1, first instance looks okay. If the class uses the default copy constructor, then the behavior is like the following examples. Some class object 1, we input 5 for the value. object 1 has this value, which points to 5. Step 2, second object is a memberwise copy of the first. What we get using memberwise copy with object containing dynamic memory, some class object 1 5, some class object 2 equals object 1. So they're both pointing to 5. Object 1 data can be lost. Modifying object 2 causes the dynamically allocated data in object 1 to be overwritten. So if we do some class object 1 5, some class object 2 equals object 1, and then object 2.setVal 13. See how object 1.getVal is also 13. Programmer defined copy constructor. The programmer can address this issue by writing another copy constructor for the class. This works better with objects containing pointers. So some class const, some class reference to object, value equals new int, asterisk value equals object dot value. A copy constructor takes a reference parameter to an object of the same class, avoids multiple ownership conflict. The same scenario results in each object now pointing to separate dynamic memory. Some class object 1 5, some class object 2 equals object 1, object 2.setVal 13, cout object 1.getVal still 5. So again, avoids multiple ownership conflict. The same scenario results in each object now pointing to separate dynamic memory. Some class object 1 5, some class object 2 equals object 1, object 2.setVal 13, cout object 1.getVal still 5, because what we did is we declared this some class with a reference object, and so object dot value is passing it by reference. Again, the programmer can address this by writing another copy constructor for the class. This works better with objects containing pointers. It's the copy constructor const some class reference object value. So if we call a class with a reference object like so, then the value is a new int, and we do asterisk value equals the object's value instead of, so we're passing the value. A copy constructor takes reference parameter to an object of the same class, voids multiple ownership conflict. The same scenario results in each object now pointing to separate dynamic memory. Got you. Safeguard the original object. Because the parameter for a copy constructor is a reference parameter, it is conceivable that the copy constructor could actually modify the object it is copying from. So again, because some class reference object, normally a programmer would want to safeguard against accidentally modifying that object. So again, safeguard the original object. Because the parameter for a copy constructor is a reference parameter, it is conceivable that the copy constructor could actually modify the object it is copying from. Normally a programmer would want to safeguard against accidentally modifying that data. To prevent this from happening, add the const modifier in the function header and function prototype, some class, double colon, some class, const, some class, reference object. Pause to reflect on object-oriented syntax. When we first learned about functions, we would pass input arguments and possibly get a value returned by the function. Largest equals max a, b. Now that we are using objects, our function invocations may look a bit different. Rectangle 1.overlap, rectangle 2. The object-oriented way of thinking involves one object calling the function and passing a reference to the other object. Operator overloading. Operators such as equals and plus and others can be redefined when used with objects of a class. The name of the function for the overloaded operator is operator, followed by the operator symbol, e.g. operator plus to overload the plus operator, and operator equals to overload the equals operator. Prototype for the overloaded operator should be in the declaration of the class that is overloading it. Overloaded operator function definition should be with other member functions. Operator overloading prototype void operator equals const some class ampersand rval. So return type is void. The function name is operator equals, and the parameter for object on right side of operator const some class, and we're passing the value by reference and rval by reference. Operator is called via object on left side, invoking an overloaded operator. General OO function invocation, object 1 dot some function, object 2. The operator could be invoked as a normal member function. object 1 to operator equals object 2. The function is usually invoked using a more intuitive syntax. Object 1 equals object 2. Overloaded operator can return a value. If the overloaded operator is a symbol that is normally used in an expression, then it is desirable that the operator overloaded function should return a value that would make sense in such an expression. Returning an object. As you know, multiple primitive variables can be conveniently set to the same value. Int a, b, c, d, a equals b equals c equals d equals 5. It is possible to provide the same convenience with the operator equals function. Object 1 equals object 2 equals object 3. Function should be declared as follows. Const some class operator equals const some class ampersand rval. Inside the function, include as last statement, return asterisk this, which returns a copy of the current object. Overloading relational operators. An overloaded relational operator function should return true or false. The string class also has examples of these. So operator less than, string comparison, makes sense. Overloaded array operator. It is possible to create classes that behave like arrays, but also provide bounds checking on subscripts. Overloaded brackets returns a reference to object, not an object itself. Consider the C++ string class. A familiar example is the C++ string class. This class has several operator overloaded functions. Operator equals string assignment returns asterisk this. Operator plus string concatenate returns a new string. Operator plus equals string append returns asterisk, so pointer to this. Operator pause get character at index position returns a reference to the character at the index value that was the argument. Different types of operators. In some situations, things can become complicated. Plus plus, minus minus operators overloaded differently for prefix versus postfix notation. Overloaded stream operators must return reference to iStream, OStream objects and take iStream, OStream objects as parameters. Notes on overloaded operators. You can define a particular meaning to an operator for objects of that class. You cannot change the number of operands that the operator takes. Only certain operators can be overloaded. Cannot overload the following operators. These. Using operator overloading. Operator overloading provides concise notation, which can be convenient for the user of a class, but if the wrong operators are used, or the resulting class interface is not what people usually expect to see by normal mathematical conventions, then overloaded operators can make it hard to write code using your class. In general, if a well-named function is more intuitive than the overloaded operator, then use the named function. Aggregation. An object of one class is a member of another class. Supports the modeling of has a relationship between classes. The object of the enclosing class has a object of the enclosed class. For example, an object of a class called student may have a member variable that itself is an object of a class called home address. We say that student has a home address. Simple aggregation example, class home address, string address, city, state, zip. Class student, string first name, last name, home address, residence. Sample program, aggregation example, aggregation in UML diagrams. So introduction to project 2, which is what I need to work on. Develop an interactive program, utilize this. Okay. The strategy. Cool. So I think that means I can be done now. Inheritance, polymorphism. I mean, look, I allocated some time. I'm nearing the 3-hour mark. These aren't that long. I might as well just get through them. Bang them out. Let's do it. Inheritance, so chapter 15, inheritance, polymorphism, and virtual functions, part 1. Online reference information, blah, blah, blah. What is inheritance? Provides a way to create a new class from an existing class. The new class is a specialized version of the existing class. A class called vehicle could represent attributes and behaviors that are common to all vehicles. A class called car could be considered a specialization of vehicle. It has all attributes and behaviors of vehicle plus other attributes and behaviors that may be unique to car. Another example, insects. Our textbook describes the real-world example of insects. Two different types of insects, bumblebee and grasshopper. Bumblebees and grasshoppers both have characteristics associated with insects, but each also has their own characteristics. The is-a relationship inheritance establishes an is-a relationship between classes. A poodle is a dog, and so on. An object of a specialized class is an object of the general class. For example, an undergrad is a student, a mammal is an animal. A specialized object has all of the characteristics of the general class plus its own characteristics. Different from aggregation. With aggregation, an object of one class is a member of another class. The enclosing class has a member. That is an instance of the enclosed class. A student has a GPA. Car has a transmission. Inheritance terminology and syntax. Base class, this is the class that is inherited from, sometimes called the parent class, sometimes called the superclass. Derived class inherits from the base class, sometimes called child, sometimes called subclass. Syntax class student is the base class. Class undergrad, public student, derived class. What does a child object have? An object of the derived child class has all members defined in child class. All members defined in parent class. An object of the derived child class can use all members defined in child class. All public members defined in parent class. UML diagrams and inheritance. How would a UML diagram represent inheritance? The convention is to draw an arrow with a hollow arrowhead from the child class to the parent class. In this example, a class C object is a class B object, and a class B object is a class A object. Therefore, a class C object is a class A object. In this example, class B is the base class for class C, but class A is the base class for class B. So class B is the subclass of class A and the superclass of class C. Class hierarchies example, consider the graded activity final exam, pass-fail activity, pass-fail exam hierarchy in chapter 15. So final exam and pass-fail activity are graded activities. A pass-fail exam is a pass-fail activity and is also graded activity. Recall private versus public. When we introduced the concept of classes, we said that private members are accessible only from within the class, but public members are accessible from outside the class. A common design technique is to make most member variables private and most member functions public. Protected members. With inheritance, there's another access specifier that becomes important. Protected member access specification, similar to private, but a protected member is accessible by objects of the derived class. So now a member may have one of three possible values for its access specifier: private, protected, public. Base class access. In addition to the member access specifier, we can specify an access specifier for the derived class itself. Class access specification determines how private, protected, and public members of base class are inherited by the derived class. Base class access specifiers. 1. Private prevents objects of derived class from accessing members of base class. This is the default. Protected, more restrictive than public. Objects that are protected or public in the base class become private in the derived class. Public object of derived class can be treated as object of base class, not vice versa. The textbook discusses several examples regarding base class access and whether an object of the child class can access a member of the parent class. So inheritance versus access, base class members, private X, protected Y, public Z. Private base class, how inherited base class members appear in derived class. X is inaccessible, private Y, private Z. Protected base class, right? So X is inaccessible, protected Y, protected Z, and public base class, X is inaccessible, protected Y, public Z. Constructors and destructors in base classes and derived classes. Derived classes, that is child classes, can have their own constructors and destructors. When an object of a derived class is created, the base class's constructor executes first, followed by the derived class's constructor. When an object of a derived class is destroyed, its destructor is called first, followed by the destructor of the base class. So sample program, special final exam, graded activity class, member variable, double score. Final exam class extends graded activity. A final exam object is a graded activity object. Member variables, int num questions, double points each, int nums missed. The constructors and destructors contain output statements, so you can see when they run. Okay, so sample program box demo, rectangle class, member variables, double width, double length. Box class extends rectangle. A box object is a rectangle object. Member variables, double height, double volume. Box demo has two constructors. One of the box constructors passes 2 arguments to the rectangle constructor. Default constructor, box, rectangle. So a box is a rectangle. Height is 0.0, volume 0.0. Constructor number 2, box, double width, double length, double h, rectangle, width, length. So extends a rectangle with width and length. Height equals h and volume equals k area times h. Inheritance summary. Different from aggregation. Aggregation has a relationship. Inheritance is a relationship. Access specifiers, public, protected, private. Constructors, order of execution, passing arguments to base class constructor. Okay, cool. And it's just going over the project I have to do again. So, chapter 15, inheritance, polymorphism, and virtual functions. So, review of basic concepts. We introduced the concept and language feature known as inheritance. One class is a subclass of another class. The subclass is a specialized version of the superclass. Establishes and is a relationship. Inheritance, terminology, and syntax. Base class, this is the class that is inherited from, sometimes called the parent class, sometimes called the superclass. Derived class inherits from the base class, sometimes called the child class, sometimes called the subclass. Syntax, class student, class undergrad, extends public student. I think I'm using that word right. Redefining a base class, redefining base class functions. Redefining a function. If a function in the derived class, the subclass, has the same name and parameter list as a function in the base class. Typically used to replace a function in base class with different actions in derived class. Redefining is not overloading. Redefining is not the same as function overloading. With overloading, the function signature, types of the parameters must be different. Again, with overloading, the function signature, types of parameters must be different. Ideally, objects of the base class use the base class version of function. Objects of the derived class use the derived class version of function. Base class example, grade activity. So we have this class graded activity, protected char letter, double score, void determined grade, public, graded activity, letter, empty character, score 0.0, void set score double s, note set score function. This set score takes in a double s, score equals s, determine grade, double get score, const return score, char get letter grade, const return letter. Our derived class is a curved activity. Class curved activity is a public graded activity. Protected double raw score, unadjusted score, double percentage, curve percentage. Public curved activity, graded activity, raw score. So curved activity is a graded activity. Raw score is 0.0, percentage 0.0. Void set score double s, redefine set score function, raw score equals s. Graded activity, set score, raw score times percentage. Am I thinking about that right? The raw score times the percentage, and that's how we set the score, okay? So curved activity is a subclass of graded activity. The graded activity version of set score enforces the traditional version of setting a letter grade. The curved activity version of set score adjusts the raw score by a user selected percentage, resulting in a different letter grade. For example, if the user enters 1.2 and the grade is scaled up by 20%. Problem with redefining: when a subclass redefines a function, there can be a situation where the base class version of the function is executed when the programmer really wanted the derived class version. Static binding: if a subclass has a function with the same signature, name, and parameters as one in the superclass, then the system needs a way to decide which one to use. When the default static binding is used, which function gets called depends on the type of the object variable used in the function call, but the same object invoked using a different object variable may result in different behavior. Dynamic binding: what we would usually prefer is for our program to call the function associated with the actual object instance, not the type of the variable. Make the member function a virtual member function. Add the keyword virtual to the declaration of the function in the base class, the parent class. Replace void set score with a virtual void set score. Polymorphism and virtual member functions. Virtual member function in base class that expects to be redefined in derived class. Function defined with keyword virtual. Virtual void function name. supports dynamic binding, functions bound at runtime to function that they call. Without virtual member functions, C++ uses static compile time binding. Virtual functions. A virtual function is dynamically bound for each function invocation at runtime, not at compile time. At runtime, C++ determines the type of the object making the call and binds the function to the appropriate version of the function. Virtual function syntax. To make a function virtual, place the virtual keyword before the return type in function declaration in the base class. Virtual char get letter grade const. The compiler will not bind the function to calls. Instead, the program will bind them at runtime. Polymorphism requires references or pointers. Polymorphic behavior is only possible when an object is referenced by a reference variable or a pointer. Redefining versus overriding. In C++, redefined functions are statically bound and overridden functions are dynamically bound. So a virtual function is overridden and a non-virtual function is redefined. Virtual destructors. It's a good idea to make destructors virtual if the class could ever become a base class. Otherwise, the compiler will perform static binding on the destructor if the class is extended. Abstract base classes and pure virtual functions. Pure virtual function, a virtual member function that must be overridden in a derived class that has objects. An abstract base class is a class that contains at least one pure virtual function. So virtual void y equals 0. The equals 0 indicates a pure virtual function. A pure virtual function does not need to have a function body actual code in the base class. Abstract base classes and pure virtual functions. Abstract base class, a class that can have no objects, serves as a basis for derived classes that may/will have objects. A class becomes an abstract base class when one or more of its member functions is a pure virtual function. Multiple child classes, so parent class and child class 1, child class 2. This example shows a class called parent class that is the base class for child class 1 and child class 2. The C++ language does allow multiple inheritance. It might be tempting to think about the diagram above as involving multiple inheritance. Do not be fooled. Multiple inheritance would be a situation where the UML diagram looks something like the following. Class C has two base classes, class A and class B. What is multiple inheritance? Multiple inheritance is a situation where a derived class can have more than one base class. Each base class can have its own access specification in the derived class's definition. So class cube is a public square and is a public rect solid. Multiple inheritance and constructor invocation. Arguments can be passed to both base classes constructors. So cube int side is a square side and a rect solid side. Base class constructors are called in order that they are given in the class declaration, not in order used in class constructor. Again, base class constructors are called in order that they are given in the class declaration, not in order used in class constructor. Multiple inheritance problems. Problem: what if base classes have member variables / functions with the same name? Solutions: derived class redefines the multiply defined function. Derived class invokes member function in a particular base class using scope resolution operator : compiler errors occur if derived class uses base class function without one of these solutions. Inheritance summary: static binding, compile time function selection, dynamic binding, runtime function selection, redefining versus overriding base class functions. Do not confuse with overloading. So this is talking about some homework assignments. And so, okay, I was thinking I was going to do these, but I'm at a point where I know that these are not going to be, these are not really going to be involved in this project that I need to get done today. I don't even think they're going to be on the quiz that I'm about to do. And I'm at a point where like knowledge is spilling out of my brain as I'm trying to put it in. So it would be diminishing returns to try to focus on that. So I'm at a point now where I'm gonna come here. I'm glad that this has actually been recording, but I'm gonna check out my project, maybe work on it, maybe take a break. I'm not sure, but for now,